Let's see at what time I'm going to be live. Chemistry pidikeradu customer ille it's Sulvam. Okay, when I'm going to get alive. Live. Let me check on. Hey everyone. Pranam, Suprabhatam. Good morning. Chobole Sonihal, Sasigal, Walaikum Salam, Assalamu Alaikum. Very good morning. Welcome, Vanakkam, Suswagatam. This is your Baba HSP, my dear friends. Just to let me know, everyone, if I'm properly audible as well as visible to all of you. I want to see green hearts along with some fire in the chat section if you can hear me, if you can see me. And here you can see this is our team. The best four. Just like four fingers and one thumb. Thumb is the Unacademy. Unacademy is our thumb, and that's the thumbnail, right? And we four the best. But I can see fire, the Deepavali, the green go, as well as some Kesriya color, that is being saffron color. My God, kids. Today's class is yours class by you people. So, what does it mean that you people are going to take this class? No, my dear friends. Whatever you require, your Baba will go according to that. What is the meaning of this? Whatever you know, whatever you need, whatever you know. No means whatever you want. I will not go according to myself today's class. In today's class, your Baba is not going to move according to Baba's desire. Baba is going to move according to you people demand. Whatever you are demanding, Baba will go like that. Now, whatever the choices from your side, let me say that some of you want suppose first option A, that mainly NCERT based new questions, and that to be expected in your exam. Expected, you know, kids. Now there is no choice. And plus it's the best explanation so that everyone can understand. This is the first option. Right now, don't go for it. Let me check it out. The second option is B option. Move from basics and then questions based on it. Two options, right? Now, out of these two options, A and B, I will sit in front of the chat section and let me check it out whether you are going for A option or B option. But first, use your brain. Then I will say start. Whenever I'm going to say start, at that time only you have to start, so that I can sit in front of chat and I can go through it, right? Are you getting my point, kids? First of all, just see the options and I will say start. Then only you have to mark. Oh, everyone start. Okay. So I got it. 99% students, 99% students given vote to this. Now, I got it. So I told you I will move according to you people. Now, second question. Question number 2. Question number 2. Class 11th NCERT. Let me divide into 4 portions. First, IUPAC. Second, Isomerism. Third, General Organic Chemistry. Fourth, Hydrocarbon. Fifth, Purification of Organic Compound, Geldal, Dumas. And sixth, Mind Maps. Now kids, out of these 6 topics, I will write down the options. Which one would you like to start first? Because the toughest one is GOC. GOC is the toughest one. So, want to follow the sequence? If you want to follow this sequence of NCERT, I will follow this sequence. If you say, sir, start with the GOC, then I will start with the GOC. Whatever you say, I will go like that. I will move like that, kids. Now let me sit in front of screen and check it out. Write down your options. Write down your options. Let me check it out, kids. So, thank you, Vasanta Kumar. Thank you. Okay, it's very tough. Okay, so I got it. It's very tough, kids. Very tough. So sequence. So people are going according to. Oh, very tough, kids. Now it has become very tough for me to understand. Let me write down option. Just wait. And now it has become very tough. Option A, sequence of NCERT kits. I want your clear options. And 2, start with B option, GOC. Start with GOC. Now 2 options, A and B. Just write down A or B. Okay. Now it's clear. We will start with sequence of NCERT. Now show me the green hearts along with fire. See, kids, Baba is moving according to your demand. Now see, kids, see. Show me green hearts. This is your Baba for you, kids, for you. Always those who are thinking like chemistry pedikya, organic chemistry pedikya radu customer. I would like to say it's romba sulbam. That means it's not tough. It's very easy. Now kids, hit the like button. I want to see likes. Everyone smash the like button if you love your Baba. Huge respect for you people. Baba is having huge respect for you people. Kids, everyone smash the like button. Wow, thank you. Now, before I move ahead, let me tell you, those who are new to this channel, myself, Hareen Singh Parihar, I have been teaching for the last 26 plus years. I did my MTech in 2004 with distinction, or you can say the best GPA of, and now you must be thinking, sir, MTech. Yeah, I have done MTech from HBTI Kanpur, Harcourt Butler Technological Institute. In 99, I was the gold medalist in chemistry, kids. Yeah, I passed my MSc in chemistry in 1999, and after that, JRF in GATE. Now, number of first rank, if I talk about Tanishka Yadav, my student, our student. If I talk about Mehak Arora, AIMS third rank. Younger brother of Mehak, Suez Arora, NEET fifth rank. Why I have taken that much of time? 715 marks at that time, 3 people got, right? 15 people got 715 in that year, and this year to 720, you know. Now, let's set go. Let's start. Before starting, let me tell you one more thing, kids. Just see. Unacademy Empower Your Learning this Republic Day. It's already gone, but this is the big, I will not say in a single day can decide the Republic Day. The whole week, the whole month you can celebrate as Republic Day. And flat 60% off, kids. Flat 60% off on NEET UG subscriptions with Asho. Get 12 months subscription free. If not selected, see, my God, use code HSP10. HSP10. HSP10, and this is valid till January 29 only. January 29 only. And my dear students, I would like to tell you one most important thing. We have started with this page. You know, your Ambika ma'am, you know, everyone, just do let me know. I want to see green hearts. You know, Ambika ma'am, the best teacher for biology to teach in English. The best teacher. No one is there. My dear students. Wasim sir, you know very well. Thalaiva, the best teacher for chemistry. Even I respect. I respect Wasim, my younger bro. Right? Thalaiva. Yava sir to art. The best teacher for physics and our QT teacher. You call, you know, Yava sir's name, nickname? If yes, do let me know in the chat section. And this is your Baba HSP, always dedicated for you kids, right? And join Dream Crash Course kids. I will not say it's a crash course. Better term, capsule course. I would like to say it's a capsule course, kids. In crash course, people are not means giving that much of what to say, the correct pedagogy they are not following. They are not moving from the basics. But in this crash course, better to say capsule course, we will move according to the best strategy, the proven strategy. Means starting from zero level and going for the first rank kids. Right? You must have heard one dialogue in your not Champa, sorry, which movie? Pushpa 2. Rapa means we will go with the concept and kill that question. We'll make that question easy peasy lemon squeezy. Rapa, you know that term. So 150 plus live lectures, 8 plus 10 test English, and starts on February. And just for it is available just for 2,999. So see, 2,999 means what? For one day, if you are eating samosa, and samosa is, what's the price of samosa? 10 rupees. Then calculate, it's like eating samosa per day. Now, You are ready? So that we can move, kids. Okay, let's move here, let's move here, let's move here. Let's move on. Let's move on. Just to let me know, kids. Everyone ready? Is everyone ready, kids? Show me fire in the chat section if you're ready. If everyone is ready, show me some fire in the chat section so that I can start. So that your Baba can start, kids. Everyone, wanna see some fire in the chat section? Yes, how is the Josh? That's fantastic, fantastic, kids, fantastic. Now, let's move here. So, very, very basic concepts. Let's move on with the very, very basic concepts. Very basic concepts. What are these very basic concepts? Hybridization. I will not teach complete hybridization. I will just focus on the hybridization for organic compounds. Okay, I will use just hybridization for organic compounds because it holds a whole lot of weightage. Right? Now, kids, if I ask you what is the steric number, what is the steric number? What's the steric number? What you will say, kids? What will be your answer? What's the steric number? Sn. Write down in the chat section. You will say that number of sigma bonds plus number of lone pairs. Lone pair or pairs. Agreed? Everyone agreed with this formula? I want to see in the chat section. If yes, I want to see green heart. If no, then fire. Let me check it out. Green heart or fire? Fast. Sahana is showing green hearts. Sahana is the first one to show green heart. Then Avinya. Kartik Yadav, fire. Amita, fire. Hafiz showing fire. Very good, Tony Fury. Now, it's a mixed reaction. What I can see, it's a mixed reaction. And kids, you are 112 and likes are only 138. Very good. Now, it's a mixed one. It's a mixed one. Now, see, kids. It's a mixed one, then I would like to say this is wrong. This is wrong. Wrong, kids. It's wrong. And that's why your organic questions and number of questions you are getting negative marks. Now, kids, you will say, what is this? How it is wrong? Yeah, kids, it's a wrong. Now, see, kids, what's the correct one? Steric number is number of sigma bonds plus number of lone pairs or pair, but we have to count only those lone pairs which are localized, which are being localized. Now you will say, sir, what is this localized? What is this new term? We have to never thought of this. Yes, kids. And that's why this is the thing which is killing your marks. This is the thing which is killing your marks, and that's why you're never getting that confidence which is required. What is this? This means those lone pairs which are localized, Localized. Now you will say, what is the meaning of localized? What is the meaning of localized? You will say, what is the meaning of localized? Kids, localized means not doing resonance, not involved in resonance, not involved in resonance. This is the meaning, kids. Those lone pairs which are not involved in resonance, only those lone pairs can be counted. Remember that if the lone pair is doing resonance, you can never count in the hybridization. Now ask me why. Ask me why. Pucho kyun? Pucho kyun? Pucho kyun? Now let me tell you, kids. Let me tell you. See, if I talk about that, if this is the compound CH3, CH2 and H2, and see, if this is second compound CH2 double bond CH and H2, see, both are the nitrogen. In A also there is nitrogen, in B also there is nitrogen. It is having 3 sigma bond, 1 lone pair, 3 sigma bond, 1 lone pair. Now kids, see, this nitrogen's hybridization is sp3, but at the same time this nitrogen's hybridization is sp2 only. Now you will say, why? Pucho kyun? Pucho kyun? Kids, how many of you want to go in detail? I can simply say, I can write this is being localized and this is being delocalized. But how many of you want to know the detail? If you want to know the detail, write down in detail. Write down in detail. Fast, kids, fast. If you want to know in detail, write down in detail. Everyone, kids, you know, only between you and me, this is the medium by which we can understand the things. Kids, fast. Fast, kids, fast. Okay, very good. Now see, kids, see. You know that electron want to move. Electron wants to move. Now there is no position to move. There is no vacant orbital in adjacent. You can say adjacent to it. There is sp3 hybridized carbon, so this electron cannot move. If this electron can't move to the adjacent carbon, it has to be the friend of rest of other 4 orbitals. But if the electron can move, see, this carbon is what? This is having pi bond. This is your pi bond. You can see this is your pi bond. So this electron can move to the adjacent carbon, and if it can move to the adjacent carbon, so it will not involved in the hybridization. So it's only 3 sigma bonds are involved in hybridization and lone pair is not involved in hybridization, right? So it will move to other atoms, it will do resonance, so it is only sp2 hybridized. Now see how it is going to affect your rest of the chemistry. Just see to it. If I talk about, this is your compound, this is your compound, and this is your another compound. Now just see, kids. Now see, everyone, just see. Just see. In this, the adjacent carbon, they are being sp3 hybridized. So this 1 sigma, 1 more sigma, 1 more sigma, and steric number will come out 3 sigma plus 1 lone pair, so 4. So it is sp3 hybridized. It is tetrahedral or pyramidal? Pyramidal, right? And here, if I place here pi bond, this is your pyrrole. Pyrrole. Now see, this lone pair will do resonance. So we will say it is delocalized and it was localized. So only one sigma, one more sigma, one more sigma. So steric number is coming out 3. So it is being sp2 hybridized and it is planar. And the whole ring is planar, and that's why we call this pyrrole to be aromatic. Because for aromaticity, the first rule required that all the atoms of the ring should be planar. But here, all the atoms are sp3 hybridized. So it's not planar. Is it clear? Is it clear? Is it clear, kids? Do let me know in the chat section. Is it clear to each and every one of you? Hey kids, keep on showing green hearts if it is clear. If it is clear to each and everyone, I want to see green hearts. Kids, fast, fast, fast. Now, very good. Now, very good. Now, if this is clear, let me give you one question. Let me give you one question. Question is, find out hybridization of first carbon. First carbon compound is CH2 double bond CH2 CH double bond CH C triple bond CH. This is the compound. Options are A option sp3, B option sp2, C option sp, D option all of these. Your favorite option. See the question properly and go for the answer. Let me see in the chat section what answer you are going for. Fast, fast, kids, fast. Do let me know what's your answer. Everyone. Jeevan, I'm good. I'm good. Fast, kids, fast. Now see, maximum people are going for B. But the correct answer is, kids, this, your answer is wrong. This is wrong. Examiner will give you 0. Now kids, why it is wrong? Why it is wrong? Kids, you have to find out first of all which carbon is first carbon. And to know the first carbon, you should know IUPAC. To understand first carbon, we should have knowledge of IUPAC, and IUPAC says this is functional group. I will teach you IUPAC, kids. I will let you know IUPAC, right? And that's why I have given this question. And IUPAC says that we will start from that side, right hand side, because this is functional group. And from this side, 1, 2, 3, it is coming on 3. And 1, 2, 3, 4, 5, 6. So first carbon is this, second, third, fourth, fifth, sixth, seventh, eighth. And generally we are thinking that we are talking about this carbon, this is first carbon. No, he said first carbon, and first carbon, that means the first carbon of the chain. Okay, you got it. You got failed. So it is sp, sp, sp3, sp2, sp2, sp3, sp2, sp2. Agreed? If everyone agreed, wow, I want to see green hearts in the chat section if everyone is agreed. If everyone, because from here only I can see green hearts. And so answer goes C. So you know that you understand what is hybridization, but you are missing because you are not able to see question properly. You are not able to understand question properly. Now see, kids, remember that whenever we write alkane, whenever we write alkane, whenever we write alkene, and whenever we write alkyne, I am moving according to NCERT, kids. Remember that. Whenever there is single bond means sp3 hybridized, double bond means sp2 hybridized, triple bond means sp hybridized, right? Now single bond means bond length is 1.54 angstrom, bond length. Double bond means 1.34 angstrom, right? But if there is resonance, once I am going to teach resonance, I will let you know, then there is no pure single bond, no pure double bond. They are always in moving condition. So it will do resonance, that I will teach you later on, and due to that resonance, single bond is converting double bond is converting into single bond. So 1.39 angstrom. This you have to mug it up. Which length? These three lengths you have to cram. These three bond lengths you have to cram it out. मुझे तो रटना है, हे बाबा मैंने तो रटना है. Just cram it out. Done? Is it clear? Done with this much? Now my target is to tell you IUPAC. I'm going to start with IUPAC. Everyone ready for the IUPAC? Yes. IUPAC, are you ready? Everyone, are you ready for the IUPAC? Just do let me know. I want to see some fire in the chat section if everyone is ready for the IUPAC. IUPAC. Kids, oh, what's that? IUPAC. Everyone ready? Now, to understand IUPAC, we should know functional groups priority order. If you remember priority order, then it's okay. If you not having that priority order in your brain, I will tell you the trick. So you have to go with that trick. First of all, do let me know. Without that trick, you will never be able to solve any question. If you are having that trick, it's okay. And if you want, then write down you want that trick of IUPAC functional groups priority order. Fast. Gets fast. Let me know. Fast. Write down as you want. I will go like that. Those who want. Okay. Yes. So everyone requires that trick. Now see. So the first one is, number one is carboxylic acid. Number two, sulfonic acid. Third is anhydride. Fruity smell is of ester. Esters, they have fruity smell. So this is the sequence: 1, 2, 3, First four. Let's see the trick for first four. There is one car. There is Salman. Salman, and car is moving. Now see. Car is moving. Car is moving along with Salman for a better ride and height right towards the garden of Astor. Asters, they have got fruity smell. Car is moving along with Salman. Car is moving along with Salman for a better ride. Car is moving along with Salman for a better ride and height right towards the garden of Astor having fruity smell. Kids, just try it out. I don't know whether you're liking it or not, but it's very, very important. It holds a whole lot of weightage. If you don't know the sequence, you will never be able to solve the question. Let me see in the chat that are you liking it or not. I'm sitting in front of screen and I'm going to sing that. Hey, car is moving along with Salman for a better ride and height right towards the garden of Astor. Everyone just do let me know you are liking it. A car is moving along with Salman for a better ride and height right towards the garden of Astor having fruity smell. Now, if these four are clear, then I am going with other two. Fifth one is acid halide, carboxamide, acid halide, carboxamide, acid halide, carboxamide, acid halide, carboxamide. So 6 are clear. Then I will go to next page. First, car is moving along with Salman for a better ride and height right towards the garden of Astor. Acid halide, carboxamide. Now see 7th. Cyano, 8th, isocyano, 9th, aldehyde, 10th, ketone. Now everyone say cyano, isocyano, aldehyde, ketone. Cyano, isocyano, aldehyde, ketone. Let's become one small kid. Cyano, isocyano, aldehyde, ketone. Cyano, isocyano, aldehyde, ketone. Once again, everyone. Car is moving along with Salman for a better ride and height right. Acid halide, carboxamide. Cyano, isocyano, aldehyde, ketone. Kids, some of you must be thinking like, Baba, speed, please increase the speed. Remember that accuracy matters a lot. Try to keep the things in your brain, in your hippocampus, in your hypothalamus. Once the things are in your brain forever, speed will automatically increase. Remember that. Don't go for speed right now. Show your speed in the examinations. Once the accuracy is there, speed will always be there. Is it working, kids? Is it working? Kids, do let me know, is it working or not? I want to see your messages, kids. I want to see green hearts if you're really liking it. Now, 11th. 11th is having alcohol having alcohol. Mercapto, मर गया captain, mercapto, having alcohol, drinking alcohol, mercapto, Amen. Amen. The world has become unsaturated. The world has become unsaturated. Unsaturated, that is olefins and acetylenic bond. So this is the sequence, kids. This is the sequence. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14. And remember that these double bond and triple bonds will always be like primary suffix. They will always act as primary suffix. Now, who will act as secondary suffix? Remember that all 14 are clear. If all 14 are clear, if all 14 have gone to your brain, let me tell you, kids, let me tell you, if all 14 have gone to your brain, then see, remember, very, very important note. I am going to give you very, very important note. This holds a hell lot of weightage. Only the senior most functional group will act as what? Fill in the blank. Will act as what? Will act as secondary suffix. Remember that only the senior most functional group will act as secondary suffix. Remember this point. Rest of functional groups or functional group or groups, if present in the parent chain, if present in the compound, then they will behave as prefix, mind my word, prefix, and their name will be written just like substituents. Their name will be written in the alphabetical order, just like substituents, substituents. Remember that this is very, very important thing. If this is clear, then I will tell you and I will give you question, and maximum people do mistakes. Should I give you question? Are you ready? And I will show you that where you are doing mistakes. Just do let me know. Should I give you questions? And you will definitely do mistakes. Okay. Now, before, okay, you are ready. Before giving you questions, let me tell you the format of writing IUPAC. Remember that format of IUPAC. Word root, and after word root, primary suffix, and after that secondary suffix, and before that prefix, and before that position of prefix. Okay, This is the order. Let me tell you each and everything so that you should not make mistake. This is primary suffix is always double bond or triple bond, and remember that the secondary suffix is always senior most functional group. And who is going to be prefix? Who is going to be prefix? Remember that prefix is alkyl or nitro or alkoxy or junior functional groups. Now kids, this I have told you. Now then also you will do mistake. Then also you are going to do mistake. Now let me show you kids. Let me show you. Okay, let me show you your mistakes. Now, compound is visible to all of you. The question is kids, find out position of mercapto. Mercapto, you know, that is SH. Options are option A 6, option B 4, option C 3, option D 2, option E 5. These are the options. Do it. Let's see. Do it. Let me check it out. How many of you are going to get pass? Fast. I'm waiting for your answer. Let me see how many of you are getting pass. Get fast. I want to see your answer. So A is being marked, B is marked, D is also marked. All the options are marked. You have marked all the options. This is your knowledge. Now see, who is the senior most functional group over here? Who is the senior most functional group? So definitely the senior most functional group is this one. This is senior most. So this will be secondary suffix, and I will say this to be 1. This to be 1, right? Agreed? And remember that whenever you are going to do numbering, secondary suffix, then multiple bond, and then prefix. This is the sequence. Remember this. This is the sequence. Preference order should be like this. This is the preference order, right? You have to move like this only. So secondary suffix, after going through secondary suffix, this is junior functional group. Junior functional group. So you will see junior functional group or the multiple bond first. Whom you will see first? Multiple bond should get importance after secondary suffix, or this prefix. Junior functional group are always treated as prefix. So 1, 2, 3. 1, 2, 3, 4. Vana, Randa, Monu. Vana, Randa, Monu, Nale. एक, दो, तीन. एक, दो, तीन, चार. So 2, 3, 4, 5, 6. So 6 is the correct answer. Those who have got it correct, green hearts. If your answer gone wrong, fire. If your answer is correct, green heart. If your answer gone wrong, fire. Kids, everyone, we have to be very transparent. Show your transparency. Then I will give you one more question. Then I will give you one more question, kids. Now, question number 2. Now, just see the question, and question is, find out position of OH in the parent chain, PC. PC means parent chain. Options are 1, 3, 5, 4, 6. Just see, kids, just see how much you are going to score. Let me check it out how much you are going to score. Now, kids, almost all the options are getting clicked. Now, let me check it out what the answer is correct. Now, see, COH will get number 1. COH is secondary suffix, senior most. So, this, neither one or from that side 1. But after that, this is junior functional group and this is alkyl. Both will be treated as prefix only. Both will be treated as prefix only, kids. Am I right? Am I right? Am I making sense? Because it is senior most. So secondary suffix, this is senior most. So secondary suffix. Now these are junior. So its name comes hydroxy. Its name is hydroxy. And its name is ethyl. Who comes first? A, B, C, D. You know A, B, C, D. A, B, C, D. E comes first. So 1, 2, 3. 1, 2, 3. Numbering rule got failed. Locant rule, lowest sum rule or locant rule also got failed. Then apply alphabetical order. Alphabetical order. Who comes first? This comes first. So we have to go like this. 1, 2, 3, 4, 5, 6, 7. So hydroxyl group is coming on 5. So 5, 5, 5. So this option is correct. How many of you got it correct? Green hearts. If your answer went wrong, fire. Let me check it out. Green hearts or fire? Green hearts or fire? Ha 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 ha. Kids, you are enjoying it or not? Really, it's going good. Really, you are realizing your mistakes. Now another one. Just see another one. If there would have been, if I would have been IIT in Mumbai, Baba, you got it. It's right or wrong. Everyone, your answer is now. Question is, find out position of butyl in parent chain, that is PC. Options are option A 3, option B 4, option C 5, option D 6. 4 options are there. Let me check it out. How many of will you be able to do it? Fast, kids, fast. Today is your exam. Just you can take it as your exam. Your final exam is going on. Your final exam is going on. Kids, just treat it like a final exam. Just treat it like a final exam is going on. See to it. Everyone just see to it. Now, there is no functional group. So this is double bond. This is double bond. Now, at this double bond, there is alkyl group is also attached. And if I give 1 to this double bond, there is no alkyl group. So, the double bond along with alkyl will get preference. Double bond along with alkyl will get preference. And my mind is saying that I should go like this. But double bond says without counting both the carbon, you can't move. So this I have to give number 1 because here double bond plus alkyl group, double bond plus alkyl group. So 1, 2, 3, 4, 5, 6. So 5 position. This is butyl. 1 carbon, 2 carbon, 3, 4. This is your butyl and butyl kits. So 5th position. So this is the correct answer. How many of you got it correct? Kids, don't forget to show me green hearts or fire. If it is correct, green heart. If it is wrong, if bent wrong, fire. Kids, fast, fast. Now, let me move towards another one. Kids, really, if you're getting benefited, I want to see fire as well as green hearts. Kids, you know that what I said. Whatever I will do for you. I will do for you. I will clear your mistakes so that you should not make out mistakes. Now, let me tell you some basics. Suppose if the compound they have asked, if compound is given like this COOH, CH2, CH2, CH2COOH. I will write down the names. You have to tell me which name is correct. 1, 2, 3, 4, 5. I will write down names. You have to tell me which name is correct. A pentane 1,5-dioic acid. B pentane dioic acid. C starting with a small p, pentane dioic acid. And D pentadioic acid. Tell me which one is correct. Let me check it out, kids. Let me sit in front of screen. Fast, fast, kids. Now, kids, let me tell you, all of you got failed. Categorically, I am telling you this particular thing, that all of you got failed because all the 4 names are correct. All names are correct. Now ask me why. All they are correct. Ask me why. पूछो क्यों? पूछो क्यों? Kids, this COH line will start from here and line will get ended over there. There is one famous dialogue of Amitabh Bachchan. Hey, organic compound में जहाँ पे हम खड़े हो जाते हैं लाइन वहीं से शुरू होती है और लाइन खत्म कहाँ पे होती है? जहाँ आप खत्म होते हो वहीं पे लाइन खत्म होती है. The line will start from here. This is being the starting point and this is the ending point, kids. So name means with the name, if you are able to write down this structure, then all the names are being correct. If you are able to write down the structure from the name, then all the names are being correct. So if the first carbon is COH and the last carbon is also COH, so whether you write down its position or you are not going to write down 1,5 doesn't matter. And IUPAC says the first letter should be capital, no other letter should be capital. But IUPAC says if all the 4 options starting with small letters only, then they are correct. If all the 4 options they have given is starting with a small letter, then also it is correct because all 4 options are given over there. No other letter should be capital. If it is clear, I want to see green hearts. If not clear, fire in the chat section. Green heart of fire. Fast, quick, kids, quick. Now, if the name would have been given like this, COOH, CH2, CH, COOH, CH2, COOH. Now remember that in this name there are 3 COH and all the COH you won't be able to count. All the COH you won't be able to count. Then remember my words, mark my words. In this situation, there is one remedy. Let me tell you what's that, kids. In situation wherever senior most functional group can't be counted, in the parent chain. In the parent chain, we will use chemical abstract name. We will use what? We have to use chemical abstract name. Which name? Kids say, which name? Everyone speak it out. Chemical abstract name. Which name? Say everyone. Chemical abstract name in place of secondary suffix or as secondary suffix. Everyone say. In this way, I am not going to teach. Everyone, wherever you are seated, everyone say which name? Chemical abstract name. Now, in this thing, we will not count COOH. We will take this as the parent chain. We will just take this as the parent chain. This much as the parent chain, because COH is attached, COH is attached. Remember that COH should be, COOH must be directly attached to the parent chain. And we will say 1, 2, 3. So its IUPAC name will be propane 1, 2, 3 oic acid. He will give you oic acid. Don't go for that. Try carboxy. Never go for that. Then what? Try carboxylic acid. Try carboxylic acid. So carboxylic acid, its chemical abstract name. Clear, kids? You are my respected future doctors, some engineers. Kids, do let me know. Everyone, are you able to understand, kids? I love you. I respect you, kids. I'm sitting in front of screen. Just do let me know you are able to understand. Everyone, your response is very much required, kids. Now tell me in the chat section, you are really getting benefited or not. Thank you, Sahana. And write down, you are really getting benefited, because your understanding is my prime requirement. The first thing which is required for me is your best understanding, kids, your best understanding. And at 2 p.m. I will give you break. Okay, first make a promise that you will not go in between that, kids. I want to make some points very clear, that meanwhile you are not going to leave. You have to show your dedication so that I can make you perfect. Make a promise. Make a promise. At 2 p.m. I will give you one break, first break. At 2 p.m. I will give you first break. Everyone, DJ Tilu, wow, thank you. Now, see, kids. Now, if it would have been like this, remember that. If it would have been given like this, kids, if the question would have been given like this, see, kids. Everyone see. And they have given you COOH like this. Now remember that in this case, you will say this is 1, 2, 3, 4, 5, 6. And how will you do its IUPAC? Cyclohexane cyclohexane. Some of you will say cycloheptanoic acid. No. Cyclohexane carboxy. No. Cyclohexane oic acid. No. Cyclohexane and its chemical abstract name. What's that? What's that, kids? Carboxylic acid. Cyclohexane carboxylic acid. But if the same compound would have been given like this, remember that. If it is given like this, kids, the same compound would have been given like this, CH2 COOH, then it is going to be a problem. Then it is going to be a problem, kids. It will create a problem for you, kids. Now what you will do? How will you do its name? Remember that in between the COH and the cycle, this is the cycle, and that is the functional group, senior most. There is obstacle, this is obstacle, this is the obstacle. It is breaking, break up. There is breakup. Now what you will do? Now you have to choose, you have to select either that as the parent chain or this as the parent chain. Who is having something more important, something of more importance than COH is having more importance, then you will say 1, 2. That's it. This is your PC. This is going to be a parent chain. Now this will not be the parent chain. Are you getting my point? Everyone, are you getting my point, kids? Now 2-cyclohexyl. Ethanoic acid. It's clear? It's clear? Is it clear to all of you, kids? Do let me know in the chat section. Is it clear, kids? Is it clear to all of you? Hare Baba. Yeah, what's your doubt? Everyone, you are free to ask any doubt. Muhammad Irfan, fast. Everyone is free to ask doubt. Kids, any doubt? That's why I'm coming and sitting in front of the screen. Any doubt, you are free to ask. Okay. Now see, kids. Now see. I think this is clear. Now another question comes. The most important thing. See, journal names of dicarboxylic acid. Journal names of dicarboxylic acid. It holds a hell lot of weightage. Very, very important, kids. Very, very important. See. COOH. We all know its name. Oxalic acid. One CH2 and COH, 2 CH2 and COH, 3 CH2s and COH, 4 CH2s and COH, 5 CH2s and COH. They will give you general name and they will ask IUPAC. Are you getting my point? They will give you journal names and they will ask IUPAC. So we should know the structure. If we don't know their structures, we will get failed. Now, this is oxalic. This is malonic acid. Remember that, not malic, malonic acid. succinic acid. Glue. You will say glutamic. No. Glutamic acid is amino acid. Glutaric. Now, adipic acid. This though you know very well. P-malic acid. Now, how will you remember it? See. Ohms. Everyone say ohms. Gap. Everyone say ohms. Gap. Ohms gap. Now, how will you remember Ohm's gap? That is also tough. So let's make it smart. Number of CH2s. You can see there is 0 CH2. 0, then 1, 2, 3, 4, 5. Number of CH2s 0, 1, 2, 3, 4, 5. Ohm's gap. Now how they will ask question? They will ask question IUPAC of adipic acid. Now you know very well that how many COH are there? 2 and 4 carbons. So hexane 1,6-dioic acid, or 1,6 you want to write or don't write. Hexane dioic acid. Or hexane 1,6-dioic acid. Is it clear to all of you kids? Just to let me know, is it clear or not? Fast kids. And in this way, if you got benefited, Ohm's gap. DJ Tillu is saying this trick is really awesome, kids. Everyone, if you're really liking these tricks, the way I am teaching kids, this is a unique way. Very unique way, kids. If you're really liking it, then appreciate and hit the like button. Make it 200. Yeah, session PDF I will provide. Isomerism also I will start, but let me complete it. Let me clear it then. Okay. Now, where you will find difficulty, see, you will find difficulty whenever name of aldehyde is coming, name of ester is coming. So see, ester IUPAC name is very, very difficult. Ester. Now see, if I write like this, CH2 double bond CH, CH2 CH ethyl, CH methyl, CH2 C double bond O, OCH3. Now, what should be its IUPAC name? Anyone can try? Just try it out. You will find very difficulty to write down its name. You are going to find out difficulty. Now remember that in ester there is breaking of carbon, so always write down its name without applying any brain, without thinking a lot. This name will be written first. This name, whatever its name, whatever is the alphabetical order, doesn't matter. Alphabetically, don't go for it, just be aware of it. Its name will be written first. So methyl. Now once that name is written, kids, now apply brain. Number it 1, 2, 3, 4, 5, 6, 7. So here is ethyl, here is methyl. Who comes first? Ethyl will come first or methyl will come first? Definitely this ethyl. So 4-ethyl, 3-methyl, then 7, hept or sept. Hept. Now multiple bond is at on 6th position. This is multiple bond. So 6, hept, 6. It is on 6 as well as 7, but 6 is coming first. So hept 6. NEO8. Now see, in English there are 5 vowels, but here A, E, I, O, U, Y, 6 vowels. 2 vowels can't come together. So in, this is the tail, and O8, it's the head. So remove tail. Tail will not be there. This E will not be there. How many of you got it? Kids, do let me know. How many of you got this name? How many of you got it, kids? Everyone, just do let me know how many of you got it. It's clear. Clear. Now when ester is coming as a prefix, ester as prefix, see, ester as prefix, ester as a prefix, ester as a prefix, see kids, CH2 double bond CH, CH2 CH, C double bond O, O CH3 CH2 CH2 COOH. How will you write down its IUPAC name? Thank you, kids. Thank you. How will you write down its IUPAC name? Now, your target must be to find out who is the senior most. So for that, car is moving along with Salman for a better ride and height right towards the garden of Esther. Acid halide, carboxamide, cyanoaldehyde ketone, drinking alcohol, mercaptoamine. So car is moving along with Salman. This is the senior most. So will be used as secondary suffix. This is ester. This is ester. Ester. Junior functional group. Am I right, kids? So will be used as prefix. Now, and this is multiple bond. So primary suffix. Am I right, kids? If this much is clear, then just do the numbering and you will get the IUPAC name. There is no problem. No problem at all, my dear students. Just do the numbering. Hey, 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 hey. One, Naranda, Monu, Nale, Anche, Are, Ere, Hepta, Hepta, Septa. Now, how will you name this? This much is carboxy. Everyone say this is carboxy. Or carbo, you can say carbo alkoxy. So methoxy. So what do you call it? Once again, let me write down methoxy. So you will say 4 at 4 carbo methoxy, then hept 6 and 1 oic acid. Am I right, kids? If your name is also this one only, show me green hearts. If your name is not coming like this, fire. Let me check it out, fire or green hearts. Kareem, 4 methoxycarbonyl. Oh, alkoxycarbonyl also you can write. Very good. This Kareem kid is very good. So you can write carbomethoxy or you can say methoxycarbonyl also. Very good. Or methoxycarbonyl. There are two primary suffixes, carboalkoxy or alkoxycarbonyl. Carboalkoxy or alkoxycarbonyl, both are correct. Both are equally correct. Now, let me move towards very important aldehyde IUPAC kits. Aldehyde IUPAC because it holds a lot of weightage. Why it is important, let me tell you kids. Aldehydes secondary suffixes. What is secondary suffix? Anyone from public side? Secondary suffix is al. But prefix, when the time comes out for prefix, aldo or formyl, and remember that in special cases, this is very important. Oxo in special cases. Okay. Now, should I give you one question where you will get failed? Everyone is going to get failed. 90% people are going to get failed. Should I give you one question where 90% of you are going to get failed? See, first question. IUPAC name of valeraldehyde. IUPAC name of valeraldehyde. Anyone? This is the question. Answer. Let me see the chat section. Anyone is going to give the answer. Let me check it out. Who is going to give answer? Valeraldehyde kids. Yes. Let me check it out. Who is going to give the correct answer kids? Valeraldehyde. Quick kids. Fast kids, fast. Pentanol. Wow, very good. If you know what is valeraldehyde, you can answer it quickly. Valeraldehyde is CH3, CH double bond O. 1, 2, 3, 4, 5. Pentanol is the answer. Those who know the journal name, they can answer it. This is known as journal name, trivial name. Now, another question. Are you ready for another question? Everyone, see it. Second question. CH3, CH double bond O, CH2, COOH, its name. Okay, let me do the numbering. You have to tell me numbering is right or not. 1, 2, 3, 4. Should I go this side or upside? I have gone for upside. Tell me this numbering is right or wrong. So 50% people will say this is wrong, but remember that this is right. See why? In this way, I have got two prefixes, one prefix over here and one prefix over here. But I have counted this aldehyde's carbon, that is the parent chain. Who is left? Only oxy is left. Oxy. So spatial name, its spatial name I have to write down, and spatial name is oxy. So its IUPAC name turn out to be, what's IUPAC name? Yes, 4-methyl 5-oxy. 4-methyl 5-oxy and pentanoic acid. Last but not the least, I am going to give you one question, and there definitely you are going to get stuck. Everyone ready? Ready for that question? Ready for that question? See, the question is, COOH, CH2, CH double bond O, CH2, CH2H5, CH2, COOH. Which side numbering is right? If I do numbering from left hand side, 1, 2, 3, 4, 5, 6, 7. If I do numbering from right hand side, 1, 2, 3, 4, 5, 6, 7. Which numbering is correct? The left hand side or the right hand side numbering? This is right hand side numbering, and that is being left hand side numbering. Tell me, everyone, which numbering is correct? The ball is in your court, kids. The ball is in your court. Let me see who is genius. Let's see this time who is genius, kids. The ball is in your court, kids. All my dear students, do let me know which one is correct. Kids, fast. I'm saying that 99% kids are going to get failed. 90% of you will get failed. Same. Let's see, 90% are going to get failed. See, kids. Tell me which IUPAC name is correct. Which IUPAC is correct, okay? A is 3-aldo 5-ethyl heptane dioic acid. B 3-ethyl 5-formyl heptane dioic acid. C 3-aldo 5-ethyl heptane 1,7-dioic acid. D, all of these. Now your most favorite option, all of these. Most favorite option, all of these. Let me check it out. Who is going to get passed over here? Chinapagu. Chinapagu is correct. Chinapagu, you are correct. Meghumi, Srustublisi. The answer, correct answer is all of these. All of these is the correct answer. Kids, today what's happening with you? Most of the time you are getting failed or not? Most of the time you people are getting failed or not? First of all, do let me know. Most of the time you people are getting failed or not? See kids, if you say Aldo, then Aldo will come first. Then the numbering will go from this side. If you call it formyl, then ethyl. Ethyl will always remain. Ethyl will start with E. But it is having two names, Aldo or formyl. So it based on its name, which name you are using. So all are correct. Really, this mistake you would have done or not? You would have done this mistake in the examination or not? Kids, do let me know and say thank you to Baba. Shruti Blissy, thank you. Say those who got it. Really say thanks to Baba, kids, if you're really getting help. Those who are thinking that they know IUPAC and those who are really getting help, kids, say thanks to your Baba. Megumi is writing, but sir, if you don't count carbon from Aldo, no, Aldo is junior functional group, so it will remain as prefix only. See, one kid has asked, see, this is senior most, this is senior most, that is senior most, this is prefix, junior functional group, so it will count it as prefix only. So we cannot do the numbering from here. We cannot do the numbering from here. Okay, those who are really getting benefit. Then, now, any special demand from this? Any special demand from this? Now, where you are going to do mistake, let me tell you. Let me tell you one more thing where you will do mistake. The points where you people are doing mistakes, let me tell you. Now, by chance, if the compound is like this, CH3 NH CH2 NH CH2 CH2 CH3, what name will you give this? This compound is 2-degree amine. Is there anyone who can tell me the name of this compound? Very tough. So remember that 2 times nitrogen is coming. 2 times nitrogen in the acyclic compounds. In acyclic compound, if it is coming twice, 2 times or more. And if I talk about in cyclic, if it is coming even for once, in cyclic it is coming even for once like this or twice, then also we will call one name, and that name is known as AJA system. Which system? AJA system. In this system, nitrogen is counted as carbon. Nitrogen is counted as carbon, kids. Nitrogen is counted as carbon. From where nitrogen is starting first? 1, 2, and from that side 1, 2, 3, 4. So we will do the numbering from left hand side, and we will call it 1, 2, 3, 4, 5, 6, 7, 8. Wherever we have counted nitrogen as carbon, we'll write down 2, 5 di as a octane. Here 1, 2, 3, 4, 5, 6. 1 as a cyclohexane, and there from anywhere you can count 1, 2, 3, 4, 5, 6. So what's the name? 1,4-diaza cyclohexane. It's clear? This AJA system is clear. First of all, do let me know. I am in front of screen. Kids, do let me know. Is AJA system clear to all of you kids? Everyone, do let me know in the chat section. It is being clear to each and every one of you. Sahana, thank you. Now, like as a system, let me move towards ether. Many people were always demanding for IUPAC name of ether. Ether. Now see kids, it's not ester, it is simply ether. Ether. Now see kids, if I say, if ether is like this, CH3O, CH2, CH2O, CH2O, CH2, CH2, CH3. Now, how many oxygen are there? This is not normal ether. It's abnormal ether. So, once again, you have to go for oxa system. Which system? Oxa system. Now, in oxa system, oxygen is counted as carbon. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why I have counted from that side? Because it is coming earlier. So I will write down its name. 2, 5, 7, trioxa decane. Is it clear to all of you kids? By chance, if it is not given, tetrahydrofuran is given. You know tetrahydrofuran? THF. You know very well this is THF, tetrahydrofuran. And if they are asking what is the IUPAC name of THF, 1-oxacyclopentane. 1-oxacyclopentane, right? Now, let me give you one question for you people. Tell me what should be the name of this compound, everyone. Tell me what should be the name. What should be its name? So definitely 1, 2, 3, 4, 5, 6. 1,3 dioxa cyclohexane. Clear kids? Clear? Clear to each and everyone? I want to see green hearts kids if it is clear. If it is clear, green hearts. Now, special type of ether. That is highly unstable kids. What's that? Just see. If I give you 3-membered ether like this, CH3, CHO, CH2, CH3. Now see, there are 2 types of names for this compound. 2 types of names. Let me write down both the 2 types of name. I don't know examiner is going to ask which name. One is, you can do the numbering like this. 1, 2, 3, 4, 5. Now this is known as epoxy. Epoxy, where it is located? on second and third, so we'll say 2,3 epoxy pentane, right? 2,3 epoxy pentane. This is one name, 2,3 epoxy pentane. Another name, they are counting this to be oxyrane. Oxyrane. Now, only this much, 3-membered ring. Oxyrane as 3-membered ring. Now kids, 1, 2, this is coming as methyl. 1, 2, this is coming as ethyl. Which will get preference, ethyl or methyl, alphabetical wise? One side ethyl, one side methyl. So definitely E comes first in the dictionary. So we'll go like this, 1, 2, 3. So we will say its name is 2-ethyl 3-methyl oxyrane. I hope everyone got it. If this much is clear, show me green hearts in the chat section, kids. Fast. Yeah, definitely. If you follow this channel, you will get more than 700. One kid got more than 715. Thank you, Digitellu. Thank you, Digitellu. I will tell you all those things. Shruti Blishi, thank you. Very good. Now, one very special type of ether I am going to deal with. Ether, very special type of ether. It's known as crown ether. Have you ever heard the name crown ether? Because this time paper will come a little bit on tougher side, kids. So you should know each and everything. Crown ether. Now crown ethers are used as polar aprotic solvents, and these are the polymers. And you know that polymer is made up of monomers. So monomeric unit is OCH2 CH2 whole N, and the value of N should be equal to or greater than 4. मतलब 4 होना चाहिए कम से कम, 4. Okay, value of N should be equal to or greater than 4. Now see kids, let me draw it. Why it is known as crown ether, I will show you that also. It's looking like crown. Crown, it's looking like crown. Now here also looking like crown, here also looking like crown. Now see, now its name is written as X crown Y, where X is number of oxygens. So how many oxygens are there? 4. Crown. Now Y is number of oxygen plus carbon. Y is being number of oxygen plus carbon. So how many carbons? 4, 2, 2 to 4, 2, 8 and 10, or 8, 2 to 4 to 6 and 2, 8. 8 carbon and 4 oxygens. So total 12. This is its name. Clear or not? Is it clear or not? Just to let me know, kids. Is it clear or not? Kids, do let me know, is it clear or not? Clear? Now kids, let me tell you cyclic IUPAC name. Cyclic IUPAC. You got tired, I think. Kids, how's the Josh? Do let me know first of all, how's the Josh? How's the Josh? Good? Okay. Cyclic compounds IUPAC. Now let me draw one ring. Just see if I draw like this. 1, 2, 3, 4, 5. Now see, kids. Now the type of questions which can come to your brain, I am going to draw all those type of questions, right? There is possibility of these 5 type of questions. Your brain can think of these 5 type of questions. So just see. Here, this is having 4 carbons, that is having 2 carbons. So this is having more carbons. So 1, 2, 3, 4. This will be your parent chain. So 1 ethyl, cyclobutane. I hope this is clear. Now, this is having 4 carbon and that is having 5 carbon, more carbon. So that will be the parent chain. 1, 2, 3, 4, 5. So 1 cyclobutyl and pentane. Now both are having same number of carbon atoms, so this will get preference. Its dB is 1. I will tell you what is dB. So 1, 2, 3, 4. 1 cyclobutyl. No, sorry, 1 butyl cyclobutane. Now kids, this is having double bond, so more preference. So we'll say 1 cyclobutyl ethene. Now this is having double bond, so more preference. 1, 2, 3, 4. 1, 2, 1, 2, 3, 3. So its name will be 3-pentyl cyclobutene. Am I right, kids? Cyclobutene, butene. Till now, it's everything is clear, kids. Do let me know. Till now, just do let me know, kids. Till now, everyone, just do let me know. Yes, Sahana, Jyotish, Shrutplishit. Very good, very good. Hafiz sir, in batch you told 4 crown. But here you are saying 4 crown 12. 12, oh, anything you can write. 4 crown 12 or 12 crown 4. Both are correct. More number is half is. The bigger number is carbon plus oxygen. Rani is explain third one. Okay. Rani, in third one, whenever both are having same number of carbon atoms, then cycle will get preference. cycle will get preference, and why it is getting preference I will let you know. Double bond equivalent is one thing, double bond equivalent or degree of unsaturation I will teach because of that, right? Half is clear. X crown by the bigger one is number of carbon plus oxygen. Clear? I hope it's clear to each and everyone. Show me green hearts if it is clear what I can see from distance. Now after this let me tell you bicyclo. Bicyclo compounds are of two types, fused bicyclo and bridge bicyclo. These are two types, fused and bridge bicyclo. Now kids, we have to find out what is the difference between fused bicyclo and bridge bicyclo. Everyone ready to find out the difference? See, I will draw some compounds and you have to try to find it out, right? First, let me deal with fused bicyclo. Just see kids, if I'm a person who is washing clothes, you know, washing clothes, right? So I'm having two poles. Government has given me two poles, 1 and 2, and government has given me 3 wires, iron wires, so that I can give bend. You know, somebody is washing clothes, he or she needs some area, surface area to dry those clothes. So I'm having 2 poles and 3 wires. Okay, in first wire I have given one bend I have given. In second wire I have given 2 bends, and in third wire suppose I have not given any bend, no bend I have given, right? So can you see 2 cycles? And the poles, the 3 ways from where arising, they are known as bridge head carbon. So how to name it? I will say bicyclo, and the number of bends should be written in descending order. Number of bends in descending order. So it is having maximum bends 2 bends, 1 bend, 0 bend, and total carbons are 1, 2, 3, 4, 5. So pentane. Sir, I am so unable to understand. I haven't got it. Sir, I haven't got it. Okay, no problem. Let me tell you another one. So you got compound like this. Now first wire, no bend directly. Second wire, 1, 2, 3, like this, and 4 bends. Another wire, 1, 2, 3, 4 bends. Okay, now it's bicyclo, fused bicyclo. Whenever there is 0 bend, it will always be example of fused bicyclo. Now how should I write down its name? Bicyclo. Now in the examination you will get like this. So how many bends? 1, 2, 3, 4 bends. 4 dot this side. 1, 2, 3, 4 and 0. So decane. It's clear or not? So please give us one question. Okay, let me give you one question for your this. Tell me its name. Tell me, everyone, tell me its name. Let me see whether you are able to do it or not. Thank you, Sahana. Kids, everyone, hit the like button. Hit the like button, kids, if you're really liking it. G3 Jaipur, very good. Vishesh, welcome Vishesh. Oh Vishesh, you can also participate. Call everyone, Vishesh, call everyone. Yes, now see kids, this is bridgehead carbon. You can see bridgehead carbon, right? And rest of the others, you see this is having maximum bands, 4 bands. So bicyclo 4 dot, this is having 1 band, 4 1 0 and 4 1 5 and 2 7 heptane. I hope it's clear to all of you. Now I'm going to draw bridge bicyclo. Fused bicyclo I have told you. Now let's see bridge bicyclo. Everyone just see bridge bicyclo. Bridge bicyclo, everyone will have bent. All they will have bent. Just see, if I am having 2 poles, then I am giving 1 bend, then I have given 1 bend, then I have given 2 bends. Now you see, how will you call it? Its name is, everyone, bicyclo decreasing order. It is having 2 bends. It is having 1 and 1, 2, 1, 1. 2, 3, 4 and 2, 6. Hexane. Now let me draw its 3D figure. Baba is going to draw the 3D figure. Just try to understand. So this one, I'm going to draw the 3D figure. Just try to understand 3D figure, okay? Will you be able to visualize it? Are you able to visualize it? 3D figure. Tell me what's the IUPAC name of this compound? Anyone? These are bridgehead carbons. It is having 3 bend, 2 bend, 1 bend. It's going up. There is no carbon at this place. Actually, here there is no carbon, right? No carbon at this place. Remember that. No carbon at this place. No carbon. Can you get it, kids? So I will write down bicyclo. Let me check it out in the chat. Who is going to write down the correct IUPAC name, kids? Atuluru bicyclo 321 octane. Wow. Let me check it out. Bicyclo 3, very good. 2, 1, 3 to 516 octane. Fantastic, kids. Fantastic. I hope this is clear to each and every one. One more I am going to give you. One more. For your accuracy, let me check it out. How many of you can do that? This is very famous compound, and if you are able to do this one, I will feel glad. Very famous compound, kids. Very famous compound. Let me check it out. Is there anyone who is going to write down its name in the chat section? Yes. Everyone, just to let me know. Yes, kids. Fast, kids, fast. Bicyclo 2,2,1 heptane. Very good, very good. I think it's correct. Let me check it out. This is bridgehead carbon. Okay, kids. This is being bridgehead carbon. Am I right? Am I right, kids? The red one is being bridgehead carbon. Now, 2,2 bicyclo 2,2,1 2,2,4,5 heptane or septane, right? So, I hope this is clear. Now let's move towards spiro. Spiro. Everyone ready for a spiro? Everyone ready for a spiro? Let's see spiro. Spiro. Now in spiro, one carbon is common in between two cycles. In between two cycles. Let's see how. Let's see the smallest spiro. Let's see the smallest spiro, okay? Smallest spiro. This is world's smallest spiro. Now one question will come to your brain, which is smallest bicyclo. So this is world's smallest bicyclo. Now how many carbons are required for a smallest spiro? 5 carbons. Smallest bicyclo, 4 carbons, right? Are you getting my point? Smallest spiro, smallest bicyclo. Now, so one went, 2 went. So its name is spiro. Its name is written in increasing order, but both are same. So 2.2 pentane bicyclo 110 butane. I hope this much is clear to all of you. If by chance they have given question like this, it's looking like what, kids? It's looking like what? It's looking like kite. Kite. So what should be its name? 2 cycles are fused at one common carbon. Am I right, kids? This is common carbon, so its name will be spiro and then increasing order. 2.123 hexane. I hope this much is clear to each and every one of you, kids. This much is clear to each and every one of you. Do let me know, kids. Is this much clear to each and every one of you? Now, likes are 194. Make it 200, kids. 96. 4 to go. Let's see, kids. Can you make it 200, my dear students? Now, bond line notation. Only one thing is left here in this bond line notation. Let's see the bond line notation, kids. bond line notation. Do you know, have you ever heard about the bond line notation, kids? Now suppose if the line is drawn like this, if the line is drawn like this, or the line is drawn like this, all three are saying that from where the line starts is carbon and ending is carbon. So this is carbon, that is carbon, so carbon to carbon, and 3 valency, that is hydrogen. So you know that all they are ethane, all they are being ethane. Line is starting from here, getting ended, starting here, getting ended. So all of them are ethane. Right? But kids, if I say it is given like this, then what will be the IUPAC name? What will be the IUPAC name, kids? Then see, 1, 2, 3, 4, bends are there, 5, 6, 7, 8, 9, 10, 11, 12. So at 2 places methyl is there. Here is methyl, and at this place also methyl. So what should be its IUPAC name, kids? 2,7 dimethyl and dodecane. I hope this is clear to each and every one of you, kids. Is this clear to each and every one of you, kids? Do let me know. Now, let me give you another one. If they are giving compound like this, see, if the compound is given like this, suppose they have given compound like this. Now, what should be the IUPAC name, kids? Will you be able to write down its IUPAC name? Now, see, we have to select the longest possible chain of continuous carbon atoms. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Okay. So 1, 2, 3, 4, 5, 6, 7. This is the longest chain. Now this is left, that is left. At both sides, ethyl is left. So we'll write 4, 4 diethyl and septane or heptane. I hope this much is clear to all of you. This much is clear. Then, if they are giving compound like this, first compound, second compound they have given like this, third compound they have given like this. Now, is there any difference in these 3 compounds? Yes, because we know that line is starting from here, so carbon, line ending here, carbon. So 2 hydrogens and 2 hydrogens, we will say ethene. Now this line is starting from here, that means there is carbon. There is carbon, and this line is starting from here. This is 1 carbon, and both together ending at the same carbon. So 3 carbons. So CH3, CH, double bond CH2. This is propane, kids. Right? Now see, this line is starting from here. So 1 carbon. This says I am starting from here. Now this saying, hey, I'm getting ended over here one carbon and that is over there. So this compound is like this CH3, CH, double bond CH, CH3. So its name is butene. This is the best name, butene. So if all these things are clear to you, then I will give you one question. Very good question, okay? Now see the question, kids. Now, if this is a question, just try to find out what should be the correct answer. Let me see in the chat. Let me see in the chat who is going to give the correct answer for this question, kids. Yes, your time starts now. Everyone. Gets fast. 3-ethyl 2-propyl hep 1,4-diene Hafiz is going like this. Shruti Bliss is going 3-ethyl 2-propyl hep 2. Okay, 2 people have already given the answer. Let me check it out whose answer is being correct. First of all, always select the longest possible chain of continuous carbon atoms containing secondary suffix if present. If not present, then multiple bond. This point is clear. Always, let me write down, select the longest possible chain of continuous carbon atoms with secondary suffix if present along with maximum number of multiple bonds. So I think my parent chain is this one. Agreed? If everyone agreed, show me green hearts. This bluish green is the parent chain. Now numbering should be done in such a way that the multiple bond should get lowest possible number. So my numbering will be 1, 2, 3, 4, 5, 6, 7. Okay. Till now it's clear. Then only I will write down the name. Just to let me know in the chat section. Agreed or not? If agreed, show me green hearts. Okay. Now agreed, then I will write down its name. See, name will be 3-ethyl and 1, 2, 3. 3-ethyl 2-propyl 3-ethyl 2-propyl hepta. Hepta, A should be there. Hepta 1,4-diene. So Hafiz and Blissy, this A was missing in your names. In your names, this A was missing. A will be there because A and E, there is consonant. There is consonant, right? There is consonant in between them, right? Are you getting my point, kids? Let me see in the chat section. Clear, kids? Yes, Hafiz got it. Rest of other people have also got it. That's really awesome. Now, one very tough question I am going to give you. Very tough question. And if this question is done by you, I will say, yes, you are genius. Let's see. It's a challenge. It's a challenge, kids. Let's see whose answer is going to be correct for this one. Yes, kids, try it out. Try it out. Let me check it out. Who is going to give the correct answer for this? This is going to be rank deciding question, kids. Rank deciding question. Let's see who is going to give the correct answer. Yes, kids. If you are able to do it, do it. Otherwise, write down. I will tell you the theory of it. Then you can do it. Write down in the chat section if you want my help. If you need my help, just do let me know in the chat section. Really, if you need my help, kids. Sahana is saying yes. Okay, Shrut Blissy is also saying good. Let me check it out. Others. Let me check it out. Others. Other kids, do let me know. Okay. Okay, Shrut Blissy is also saying okay. So let me go with. Okay, don't worry, kids. Let me go with. Okay. Others, everyone, you need my help. Just to let me know. Okay. So see, kids. Everyone, just see to it. To make this question clear, we should know few things, right? Just see. If I say this is methane, remove one hydrogen, and if it is like this is known as methyl. One hydrogen less, then this is known as what? Anyone? This is, or bivalent, this is known as what? Methylene. We'll call it methylene, or its name is methylidene. Very, very important. Methylidene. If one more hydrogen is less, then this will be known as methylidine. Trivalent, three valencies. Methylidine. methylidine. Is it clear? Same way, this is monovalent, bivalent, trivalent. Same way, if I write down this, ethane, one hydrogen less, ethyl, two hydrogens less, what do you call it, kids? This one. Either written like this or written like this. What do you call it? Remember that this is known as ethylidene. What? Ethylidene. But never say ethylene. Don't say ethylene, because this is ethylene. What happened? This is ethylene. Remember that. This is ethylene. Journal name. And ethylene, when undergoes bromination, 2-bromine. So its name is ethylene bromide. It is known as ethylene bromide, right? But if you place 2 bromines on that, then it will be known as ethylidene bromide. Ethylidene bromide. See the difference. Ethylidene bromide. Kids, see, you call it one gem together, then gem halide, geminal halide, gone away, vicinal halide. And if one more hydrogen is removed, then ethylidine. Ethylidine. Got it? Ethylidine. And this compound, if you remove one hydrogen from here, so see, CH2 double bond CH. So you can say its 2 names are there. One is ethinyl, or you can call it vinyl. 2 names for this, ethinyl or vinyl. But remember, in between carbon there is pi bond. So it is ethinyl or vinyl. Outside, then ethylidene. Clear? Ethylidene. Now, let's come back to question. Now see, IUPAC will say the longest chain with maximum number of multiple bonds. Till now it is clear. The numbering is clear. Now this is left. This is prefix. Its name will be methylene or methylidene. Either we can say methylene or we can say methylidene. Now see, there is double bond and it's starting from here only double bond. So it's CH3 CH double bond. So it is ethylidene. But here CH double bond CH2. So you can say it is vinyl or you can call it ethinyl. First of all, tell me, till now it is clear. Let me see in the chat section. Till now it is clear. Then only I can tell you the name. NBS and bromosuccinamide. Learning zone. I will come to that later on. And bromosuccinamide, that is used for bromination of benzylic or allylic carbon hydrogens, right? But learning zone, please, right now, move on with the concepts. Otherwise, you will get confused. Now, can we write down its IUPAC name? Can we try it out? Now it will be okay. Is it going to be easy now? Now is it going to be easy, kids, to write down its IUPAC name? Learning zone. It's not for Marco and Tiv. This is the wrong question. Learning zone, that question asked by you is wrong. Now kids, with this IUPAC is over, right? Now let me tell you some names so that isoalkane, remember that? Isoalkane or types of alkanes, better to write down types of alkanes. I will not leave even a single thing. I will teach you each and everything. Types of alkanes. Isoalkane, right? Iso means the smallest iso is on CH. There should be two methyls. And this R part should be simple or normal alkyl. So smallest isoalkane will require how many carbons? This much is common, CH, two methyls. This is the bare minimum part, iso. Now I can keep only one methyl over here. So whenever you write iso, now write down total number of carbon atoms. How many carbons? 1, 2, 3, 4. Don't think about number of carbons in the parent chain. Just take total carbons. So total carbons are 4. So iso butane. Is it clear? Isobutane. Now, if anyone is asking isoheptane, how will you write isoheptane? So what are you supposed to do? First, bare minimum, what portion is required? CH. Ta-ta-dan, 2 methyl, yay. Now how many carbons left? 1, 2, 3. 7 minus 3, 4. So 4 carbons. You are supposed to write down 1, 2, 3, 4. Is it clear? Now there is one iso which doesn't follow standards. Isooctane doesn't follow rules. What rules? Which rules? Rules. You're not following rules. Why, dear? Who are you? Why you're not following rules? See what happened to isooctane? CH, 2 methyl. Okay, Baba. So he's looking like to follow rules. Who said he's not following rules? What happened to him? CH2. What's wrong with you, dear? Everyone is saying you're not following rules. Hey, fool. See, this chain got bifurcated. That's why everyone says he is not following rules. This is isooctane. Mug it up, cram it. It's very, very important. Very, very important. Without this, you won't be able to do anything. Got it, kids? Got it? This is isooctane. Remember that. Now, if this is clear, let me move with the neoalkane. Neoalkane. There are only 2 neoalkanes in this world. Only 2 neoalkanes. There are only 2 neoalkanes. On one carbon, 1 methyl, 1 more methyl. Now 1 more methyl and rest of the part is CH2. This is the very minimum part. So here either you can put hydrogen or you can put methyl. So one more neoalkane, CH3, 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 CH2, and you can keep CH3. These are the two neo, just two neo. It is having how many carbons? 1, 2, 3, 4, 5. So neopentane and 6 neohexane. Neopentane, neohexane. Kids, at 2, I will give you one lunch break, big break, okay? So don't worry, kids, okay? Don't get worried, right? I will give you one big break. Now, this much is new. Now, about IUPAC, I have told you each and everything. So, let's go with the isomerism. Are you ready? Is everyone ready for the isomerism? Kids, do let me know. Hey, everyone. Have you seen Baba's energy level? Show me some fire. Now, if you're ready, show me some fire so that I can start. Wow, such a great thing, kids. I don't know. It's a new slide, and new slide's color should be with something new. Let's take new color. Let's take new color for the slide for isomerism. Which color should I keep for this slide? Let me. Ahaha, let me. No. Let me. Let me keep this color for this slide. Isomerism, oh my life. Isomerism. So let's go with the isomerism. Now, let's do the classification of isomerism. Everyone ready, kids? Let's do the classification of isomerism. This is very, very important thing. If you don't know the classification, you won't be able to do anything, kids. Classification is very, very important. How isomerism is being classified? Isomers are classified. Let's go with that. That is very, very important thing, kids. Compounds. Can you define isomerism? Can you define what is the definition of isomerism? Everyone will say compounds having same molecular formula but different structural formula. Wrong definition. That's the totally wrong definition, kids. So remember that compounds having same molecular formula but different physical or chemical properties. Or both can be different. Or both can be different. Now, my dear students, both can be different. In our school time, some teachers have taught us that compounds having same molecular formula but different structure formula. My dear student, that is valid only for structural isomerism, but we have to study stereoisomerism and conformational isomerism, that is GI, optical isomerism, conformational isomerism. Then how that definition holds good for stereoisomerism, that is wrong for stereoisomerism. But yes, if you talk about structural isomerism, just for structural isomerism, then the definition is okay. Are you getting my point? Agreed? Everyone agreed? Let me see in the chat section. If everyone agreed, just do let me know. Do let me know, kids. Am I right or wrong? Whatever I'm telling you, am I right or wrong, kids? Agreed. Very good. Very good, kids. Very good. Now see how to do the classification. How to do the classification. How to do the classification, because it needs brain. To do the classification, it needs brain. What brain is required? Just see, kids, just focus. Suppose if I say that this is Champa. She is Champa, right? She is Champa. Champa. 2 legs, 2 hands. 2 legs, 2 hands. Suppose if I say Champa's mass is 70. 70 is the mass of Champa. 2 legs, 2 hands. Now if you see another one, another face is looking like Champa only, and it's 1 hand, 1 leg, and 1 hand is over here and 1 leg is over there. Just see, let me make it more beautifully. These are the legs of Champa's legs and Champa's hands. Champa's hands, so that everyone can understand. So this is Champa's hand over here, and this is Champa's leg at this place, leg, hand over here, and 1 leg and 1 hand over here, right? Just try to understand. This is leg at this place only, 1 hand is over here, another hand is over here. And can you tell me it's 70? Then definitely that this Champa will also be 70. Am I right? Just try to see this Champa and that Champa. Both are being Champa. If this is Champa. Now what's the problem? Could you please tell me what is the problem? Just see. Till that time I'm making hands, beautiful hands. Beautiful hands, Champa's hands, beautiful hands. Champa's hands, 2 hands over here. These are the hands, these are the legs. Now, can you see any problem? Can you see? Anyone, have you noticed any problem? Just to let me know. Just to let me know. I'm sitting in front of the screen. Can you notice any problem? Just to let me know. Today I will teach you in different way, kids, so that each and everyone can you understand. Clearly you can understand what isomerism means actually. Dislocated. Yes, the difference is that the 2 hands at the same place, hand means structure is different. Structure is different. So this and that, they are structural isomers. Can we say that they are having what type of isomerism, kids? That A and B are structural isomers. Can I say A and B are structural isomers because their structure is different? One thing is clear, molecular formula is same but structure is changed. in place of hand, leg. So A and B are structural isomers. Now see, let me draw another one. Just see. If I draw like this, can you see, kids? This is X and that is Y. Can you see any difference? Can you see any difference? Where is the difference, kids? Legs are at legs position, no problem. Legs are here only, legs. These are the legs. Legs are like this only. No problem with the legs. No problem with the legs, kids. Hands. She is having both the hands on the same side. Their origin is from both the place. The origin is at the same place. This is the origin. Their origin is set from the same place. Same side. Orientation on same side. And here one is going toward this side, one is going toward this side. Orientation on different side. If I say that for few seconds, let me become champa. One champa is like this. Hands are coming from here only. One champa is like this. Another champa is like this. Not able to see. Okay. One champa is like this. This one right hand side champa is like this. See, champa is like this. Both the hands originating from here only and coming in the same direction. Another champa's hands are going like this. One is coming towards your side. Hey, now see, this champa hands coming. Champa will come to your house and champa will say, hey, wow, 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 wow. Hand same side. But this champa will come to house, will say, hey, boom, 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 boom. Only one hand will come, one hand toward that side. So hands origination is from same side, but they are not structural isomers. Their structure is same. They have same structure, and X and Y, they have got same structure. Same structure. So they are not structural isomer. Their structure is being same. Only the arrangement in space is different. So we call it cis. Its name is cis. Its name is trans. So what relation they are having? Two are sisters. Sister is the relation. If I say this is Sampa, this is Sampa, and that is Yappa, Yappa. So these are the name. Yappa and Zampa are the name. What relation they are having? They are sisters. They are GI. They are GI, geometrical isomers of each other. Like sister is the relation, geometrical isomerism is also the relation. Kids, are you getting my point? Everyone, are you getting my point? Just do let me know, kids. Just do let me know, kids. Yampa and Zampa. Yampa and Zampa. Are you getting my point, kids? Okay. So just let me classify it, and then I will give you one break. Okay, but let me classify it, and then I am going to give you one break. So isomerism. If they are having same molecular formula, then always go and search for structural isomerism first. Structural isomerism first. Okay, kids? Always search for structural isomerism first. Structural isomers are also known as constitutional. Everyone say constitutional isomers. And in this, their types are being write your famous position. Write your famous position. What is that? Ring chain isomerism, tautomerism, functional isomerism, metamerism. C. This is C. Chain isomerism and position isomerism. If compound is not having structural isomerism, remember that if compound is not having structural isomerism, then only go for, if it is not present, then only go for stereoisomerism. That is space isomerism or 3D or space isomerism. Now, stereoisomerism. Once they are not are the structural isomers, then only go for stereoisomerism. Once again, I am telling you, if they are not structural isomers, then only go for stereoisomerism. And in stereoisomerism, it's being divided in two parts. It's being divided into two parts. What are these two parts? Remember that. Configurational isomerism. What is configurational isomerism? Configurational isomerism. And second is being conformational isomerism. Now people, you should know and you should have to have knowledge about the difference between configurational and conformational. See, configurational and conformational difference is very, very important. If you don't know, you won't be able to understand anything. These two isomerism difference you should know. If one form of isomer cannot convert into another form at room temperature, for example, if you have bought medicine from the market, this is cis form, and if you keep it in at some point that or in your house somewhere where sunlight cannot come, heat cannot come, doctor always prescribe that keep it away from sunlight at a dark place or refrigerator. Otherwise, the cis form will convert into trans form. Somebody, if you have knowledge, if your father or mother is being doctor, then they call it dextrose, glucose, which they are giving to the patients. One glucose is giving ATPs 38, 36, glycolysis 10 ATPs, net gain of 2 ATPs undestroyed, net gain of 8 ATPs, and the citric acid cycle, citric acid, isocytric alpha ketogroup, whatever, right? So if you keep it in sunlight, then dextrorotative will convert into levorotatory, then it is not going to give those ATPs and its metabolic activities will get changed and patient will get died. So remember that configurational isomerism means one form of isomer cannot convert into another form at room temperature. Are you getting my point, kids? One form of isomer can't convert into another at room temperature, and it is of two types. One is known as geometrical isomerism, GI, and another is known as optical isomerism. So now my dear friends, one point is clear. Here one form can convert into another form at room temperature. One form in this, one form is easily converted into infinite forms at room temperature. Now kids, suppose if I say I am one form, but I am unable to convert into this form at room temperature. This cis form cannot convert into trans at room temperature. Then I will be the example of, yes, configurational isomerism. And if I am able to convert into this, if I keep on doing dance like this, that means all these forms are known as what? Conformational isomer. You know, number of people are doing dance like this. They are moving their neck, they are moving their body like this, they are coming like this, they are going like this. They are doing number of things. They know how to dance. That is conformational isomerism. Kids, let me see in the chat section. First of all, do let me know that you are able to understand what is this division, what this division means, kids. Do let me know. Everyone, you are able to understand how the division is carried out. What is the meaning of this division? Oh my God, you liked my dance also. So kids, Baba Sinchan, thank you kids. Now let me write down their full forms and then we will take one break. Okay, one lunch break. Okay kids, we are going to take one lunch break. Yeah, I have promised. Yes, I have promised to give you one lunch break. So break is, we will meet at 3:10. Okay, so it's a lunch break. We'll meet at 3:10 or 3 or 3:10. Tell me, let me see in the chat section, 3 or 3:10. Just to let me know, because do properly your lunch. I will also do properly my lunch. 3 or 3:10. 3. Okay, so at 3:05. Okay, 3:10. Everyone is going for 3:10. Okay, so 3:10. Let's meet at 3:10. Okay. So Okay, kids, all the best. Welcome, vanakkam, suswagatam. Kids, are you back? Just do let me know. If you're back with full on energy, I want to see green hearts. Everyone. So let's go with structural isomerism. Fast, kids. Be fast. Wow, blue hearts. Now, and isomerism, let's deal with structural isomerism. Everyone ready, kids? Everyone, are you ready? Just to let me know, kids. Are you back, kids? Just to let me know, are you back? Are you back, kids? In isomerism, we are going to deal with the structural isomerism. And in structural isomerism, kids, let's deal with chain isomerism. And chain isomerism, I would like to say that compounds having same molecular formula. Whenever we are going to deal about isomerism, then molecular formula will always remain same. Only the PC means parent chain will get changed. Parent chain will get changed. Now, for example, if anyone is asking question, find out minimum number of carbon atoms required to show chain isomerism in number A, alkane, B, alkene, C, alkyne. These are the three types of compounds, and you are supposed to find out total number of carbon atoms, means minimum number of carbon atoms required. Everyone, are you ready? Is everyone ready, kids? So, what should be your answer, kids? Thank you, Sahana. Thank you, Sahana. What should be your answer? So, if we talk about alkane, and alkyne, then the answer will be alkane is 4. Answer is 4. Alkene is 4. Alkyne is 5. Now, definitely you will ask, how, sir? How is it possible? 4, 4 and 5, just explain, sir. So I will say it's very simple, kids. It's so simple that we can find out. Just see, if I talk about alkane, then just see, if I write down C4H10, this is the smallest alkane, C4H10, which will show chain isomerism. Just see, if I write down like this, CH3, CH2, CH2, CH3, this is N-butane, and if I write down like this, CH3, CH, CH3, CH3, this is isobutane. Now see, focus over here. 1, 2, 3, 4. Parent chain is having 4 carbon atoms. 1, 2, 3. Parent chain is having 3 carbon atoms. Just see, kids, are you getting my point? Its common name is N-butane, and its common name is isobutane. N-butane, isobutane. I hope this is clear, kids. Just to let me know it's clear. If yes, I want to see green hearts, kids. And Baba is very punctual. See, with respect to timing, Baba is very, very punctual. This is your HSP Baba, not IITN or Delhi or Mumbai Baba, right? This is your Baba. Now see, kids. Now if I talk about alkene, now see, alkene, if I talk about alkene, kids, just see, C4H10, there I have written 10, yeah, so here I have to write down C4H8 because it is alkene, C4H8. So I will write down like this, CH2 double bond CH, CH2 CH3. So you see parent chain is of 4 carbon atoms. And second one, I can write down like this, CH2 double bond C, CH3. So parent chain is of how many carbon atoms? You can see 1, 2, 3. Parent chain is of 3 carbon atoms. So parent chain is getting changed 1, 2, 3, 4. So they are chain isomers C4H8. Now if I write down for C5 alkene alkyne, if I go for alkyne, kids, if I go for alkyne, now C for alkyne, can I prepare it like this? Just see, kids, is it possible to prepare for alkyne like this? See, if I write down alkyne, if I write down alkyne over here, alkyne C4H6. Now if I try to make alkyne like this, I will remove this H, I will remove this H. So see, kids, if I remove this H, I will place triple bond, this is okay, it's possible. But if I place here triple bond, what's the problem? What's the problem, kids? Can you is it possible, this compound is possible? Just to let me know, this carbon's valency is coming out to V5, so this compound doesn't exist. Just see to it. This compound does not exist. Its possibility is not there. So this is not possible. This is not possible. Are you getting my point? So with 4 carbon atoms, it's Baba is very simple person. Shubhan, thank you, thank you. Now, are you getting my point? This is not possible at all. So I have to take one more carbon. So let me increase 1 carbon. So if I increase 1 carbon over here, let me increase 1 carbon over here, kids. Let me increase carbon over here, kids. So, alkyne. So let me take C5H. How many carbons? So 5 carbons. So alkyne, CnH2n minus 2. So H8. And let's see whether it is possible or not. CH triple bond CH2, CH2, CH3. How many carbon atoms in the parent chain? 1, 2, 3, 4, 5. PC is of 5 carbon atoms. Now another one. CH triple bond CH3 and CH3. Now I have taken 5 carbon atoms, but you see here the PC is of how many carbon? 1, 2, 3, 4, 5. 1, 2, 3, 4. PC is of 4 carbon atoms. Can you see, kids? Now, I hope this point is very much clear to all of you that parent chain is getting changed. Parent chain, once the parent chain is getting changed, they are chain isomers. Now, after this, let's move towards position isomerism. Position. Everyone ready for the position isomerism? Now, if anyone is going to ask question, find out minimum number of carbon atoms required to show position isomerism in A, alkane, B, alkene, C, alkyne, D, any organic compound. These are the 4 options. There I have given just 3. Here I am giving you 4. Let me check it out. I am sitting in front of screen. Everyone just try to find it out. So definitely the answer will go like this. Answer will go like this. 6, 4, 4, 2. 6, 4, 4, 2. This is the answer. Now, I think which one you want to understand. Which one would you like to see? 6, 4, 4, 2. Let me explain. C6H14. C6H14. Position isomerism. Position isomerism, what should remain constant? In position isomerism, PC should remain constant. Position of functional group or multiple bond or alkyl should get changed. Alkyl must get changed. Position, only position should get changed. Position should get changed. Just see now, my dear students. C6H14. So parent chain should remain constant. 1, 2, 3, 4, 5. And once methyl is at this position, methyl is at second position, and second one, 1, 2, 3, 4, 5. The position of methyl group as a third carbon. Just see the parent chain over here is 1, 2, 3, 4, 5. The position is second. Here 1, 2, 3, 4, 5. The position of alkyl group is third position. So the parent chain PC is of 5. Here also PC is of 5. At both the position, parent chain is of 5 carbon, but the position of alkyl group is getting changed. This is all about alkane. Now if I talk about alkene, then I will write down C6H12. C6H12, I will 4 carbons, 1 2 3 4. I said 4 once the position is this. Another one, note C6. Why to write C6? It is possible with C4 only 4 carbon atoms. It is possible, just see C4H8. Now see 1 2 3 4. It's possible both the position parent chain is of 4 carbon atoms, but the position is first. Position of multiple bond is getting changed. Here the position is 1. Here the position is just C. If you talk about the position is second. So same about alkyne also. This was about alkene, and same will happen for alkynes also. If I talk about alkyne, then in alkynes also, that you can see 1 2 3 4 with 4 carbon atoms alkyne, and with 4 carbon atoms you can see 1 2 3 4. This is the alkyne. You can see it's very clear. Now any organic compound, if we talk about any organic compound, then it means you are free to use anything. So I will use CH3 CH. Now I will place 2 chlorine. You can place 2 chlorine, 2 bromine, 2 iodine, 2 OH, whatever, because any organic compound. And second possibility is CH2 Cl and CH2 Cl. Now you can see how many carbon atoms, the minimum number of carbon atoms, they are just 2. So I think with 2 carbon atoms, it's very much clear to all of you. Is it clear, kids? Just to let me know now. Is it okay? Is it clear to all of you, kids? Show me green hearts in the chat section. Till now it is clear. Till now it is clear. Show me the green hearts. Now my dear students, now let's talk about ring chain isomerism. Let's talk about ring chain isomerism, kids. RCI, ring chain isomerism. If you want to find out for ring chain isomerism, remember that ring chain isomers. First of all, let me tell you, all RCI are functional isomers. All RCI are always functional isomers because their functional group will get changed. Functional isomers. Now, in this ring chain isomer, remember that one form is cyclic and another form must be acyclic. Another form must be acyclic. One should remain cyclic, another one acyclic. Now how is it possible? Their molecular formula should remain same, but one form should be cyclic, another one acyclic. Let's see, for example, if I am provided with C4H8, now you can see CH2 double bond CH, CH2, CH3. You can see this is being acyclic, and if I'm going to draw it like CH2, CH2, CH2 and CH2, this is being cyclic. Their molecular formula is same, but one being acyclic, another being cyclic. My dear students, this is being acyclic, and acyclic is being unsaturated. Unsaturated means it will convert bromine's reddish brown color into decolorized, means color will decolorize. Reddish brown color of bromine will decolorize, but here it is being saturated. It will not decolorize saturated, it will not decolorize bromine water. So their function is different. It will react with bromine water, it will not react with bromine water. So their functions got changed. That's why they are functional isomers. So I am saying that all RCI are always, what? Are always, now, are functional isomers, but who will get more preference? Who will get more preference? For that, you see, if you see in the starting, I've told you that write your famous position. I've told you write your famous position. Who was having more importance? This thing I've told you in the starting only. This is the preference order, that once I'm provided with RCI ring chain isomerism and the compound is showing functional isomerism also. So who is more important out of these two? Functional isomerism is more important or ring chain. So preference should be given to ring chain isomerism. I hope this is clear to each and every one of you. Before moving ahead, just do let me know in the chat section, is it clear, kids? Is it clear or not? Just do let me know, kids. Clear, Shubhan, Hafiz, very good. Shruti Blishi, that's really fantastic, kids. Now see, now let me move towards functional isomerism. Before I move towards functional isomerism, we should know double bond equivalent. Is everyone ready to understand double bond equivalent? Because double bond equivalent will help you a lot to understand the language of chemistry. Everyone ready? Is everyone ready? To understand better the isomerism, we should know double bond equivalent. Double bond equivalent. Double bond equivalent. It's another name. Double bond equivalent's another name, kids. It is also known as degree of unsaturation. Degree of unsaturation. It is also known as index of hydrogen deficiency. Now it's short trick, not the short trick. Abbreviations, you can say DBE, DU, IHD. Now this will increase the knowledge of your organic chemistry, and it will speed up your what? Accuracy also. It will speed up your accuracy also, kids. Now just try to understand what is the meaning of this. This line is giving us an idea. This line is giving an idea about what is there. There is deficiency. You know, deficiency diseases, deficiency of vitamin A. Vitamin A is retinol. Retinol is means scientific name. Deficiency is xerothalmia, nyctalopia, night blindness. Deficiency of vitamin C is scurvy. Deficiency of vitamin D is, number of things are there. So deficiency means hydrogen deficiency is there. Now if I compare one compound, it is C6H12. It is C6H14. It is saturated compound. Kids, it's being saturated compound. That means there is no deficiency. No deficiency is there. Now if I write down C6H12, how many molecules are less? Tell me how many molecules of H2 are less? Anyone in the chat section? If I compare in between A and B, then B is having how many molecules of H2 less? Let me see in the chat section, kids. Sahana, absolutely correct. Hafi is absolutely correct that one molecule of H2 is less over there. One molecule of H2 is less, kids. That means I can say clearly that its dBE is 0. Its dB is 0 and its dB is 1. Now we got it. Now we know that before moving towards formula, we should understand that what actually dB stands for, because formula just increases the speed. We should know the accuracy. So I can write, I could have given the formula for this. Just see the formula. dBE is equal to x plus 1 minus y by 2. Now what is x and y? See, Cx Hy. This is an ionic compound where x is number of carbon atoms, y is number of hydrogen atoms. Now I will take the same formula which I have proved over there, C6H12. Its dB I will try to find out with the help of formula. So dB is equal to 6 plus 1 minus 12 by 2. That is equal to 7 minus 6. That is equal to 1. Hence proved. Now it's your turn to find out the dB. C6H14, C6H12, C6H10, C6H8, C6H6. 1, 2, 3, 4, 5. Just find out their dBs. dB, everyone, 0, 1, 2, 3, 4. Do you think these are the correct answers? Do let me know in the chat section, kids. Yes, do let me know in the chat section. Are these answers correct? If yes, I want to see green hearts in the chat section, kids. If it is correct, I want to see green hearts. Thank you, thank you, thank you, kids. Thank you. Now, this I have told you calculation of dB. Now, let's find out dB calculation of any organic compound. Any organic compound. Just see any organic compound. Any organic compounds dB, right? Now, if there is any organic compound, like if I say CX, HY, OZ, nitrogen M, and halogen N. Okay. Now, how to find out dB of any organic compound? Just see, the formula is x plus 1 remains same, minus h in place of h. Let me write down what to write down, which letter? B I have not used. B by 2. B by 2. Now what is B? What is being B? B by 2. B by 2. B is number of hydrogen plus halogen atoms. You know, halogen and hydrogen, they are in the same, means sometimes hydrogen behave as halogen also. So number of hydrogen plus halogen atoms, right? Minus number of nitrogen atoms. Now, any compound, if it is given, you can easily find out its dB, and this is very rarely used formula. Kids, generally they are going to use carbon, hydrogen, hydrocarbons, so that's very natural. Now, calculation of dB from calculation of dB from structural formula, kids, structural formula. That is equal to dB is equal to number of cycles plus number of pi bonds. So simple, kids. So simple. It's so simple. Number of cycles plus number of pi bonds. Now, if I draw any compound like this, I draw one compound like this. I draw one compound like this. And I draw one compound like this. Now there is no need to find out to go for their molecular formula. Simply by seeing the structure formula, you can find out their dBs. I'm going to write their dB: one cycle, one pi bond, 1 plus 1, 2. One cycle 2 pi bond, 1 plus 2, 3. One cycle 3 pi bond, 1 plus 3, 4. These are the dBs. Just to let me know, kids, is it clear or not? 1, 2, 3, 4. Once this much is clear, then I will let you know what is the use, how to use dB, kids. Do let me know, is it clear or not? Till now, if everything is clear, keep on showing green hearts. If not clear, I would like to see the fire in the chat section. Do let me know, kids. If it is clear, I want to see green hearts. If not clear, fire. My aim is to teach you, to tell you each and everything, kids, so that you should understand each and everything clear, my dear friends. Bruce Lee, thank you. Now, kids. Parma. Now see, kids, how dB is going to help you. dB application. dB is application. Just see how dB is going to help you, right? dB is application. Now let us suppose if I say compounds dB is 0, dB is 0, just do let me know, do you think compound can be cyclic? Only acyclic, only acyclic, only acyclic, and that is saturated, only acyclic, saturated means without pi bond. Saturated means without pi bond, without pi bond. Now can't be what? Can't be cyclic, can't be cyclic, can't be alkene or alkyne. Am I right? Can't be alkene or alkyne. Am I right, kids? If this page is clear, keep on showing green hearts fast, so that increase speed should always remain more. Can't be like this. Now if I say compounds dB is 1, that indicates it can be alkene, it can be cyclic, but can't be cyclic alkene, can't be cyclic alkene, can't be alkyne, can't be alkyne. Am I right, kids? Can't be alkyne, can't be bicyclo, can't be bicyclo or spiro, can't be bicyclo or spiro, can't be bicyclo or spiro. Am I right, kids? Now, if I say dB is 2, dB is 2. If dB is 2, my dear students, we can say if dB is 2, now dB is 2, dB is 2, that means it can be alkyne, it can be alkadine, it can be cycloalkene, it can be bicyclo or spiro, bicyclo and spiro. Till now, is it clear to all of you or not, kids? Just to let me know, is it clear or not? Now, let me give you one question and let me explain it. Just see to it, kids. Just see. If I say that I am being provided with C5H12O, C5H12O. Now, if anyone is asking, this compound will be alcohol, aldehyde, ketone, carboxylic acid, then what should be answer? Kids, do let me know what should be answer out of these four. Let me sit in front of you and let me check it out. What should be answer? Yes, kids. Which answer you will go for? Fast. Quick. Kids, if you want to get selection, if you want to get selected, if you want your best selection, fast. Vote for the answer, kids. Speed up. Speed up, kids. At Parma's answer is correct. Parma's answer is correct. Now see, kids. Its degree of unsaturation is equal to x plus 1 minus y by 2. So 6 minus 6 is 0. So can't have pi bond. This is indicating that compound can't have pi bond. Can't have pi bond. So alcohol's possible. Aldehyde require 1 pi bond. Aldehyde requires 1 pi bond. Ketone requires at least 1 pi bond. Carboxylic acid requires 1 pi bond as well as 2 oxygens. 2 oxygens. Everyone, all they require pi bond. That means dB for them should be equal to or greater than 1. So they are not possible. Only the possibility is about alcohol, kids. How was the question? Tell me. Tell me, kids. Just to let me know. Have you got it or not? Have you got it or not? If it is clear, then I will go for another question. Just see. If I say that molecular formula, suppose if I give you one compound C4H8O2, C4H8O2, then possible compound or compounds, possible compound or compounds: A, carboxylic acid, B, cyclic carboxylic acid. C, cyclic aldehyde. D, all of these. Just vote for it. Vote for it. Let me check it out. How many of you are the genius kids? Yes, A is the correct answer. Very good, kids. A is the correct answer. See why? Its dB is coming out. Degree of unsaturation 4 plus 1 minus 8 by 2. 5 minus 4 is 1. 1 pi bond. Only 1 pi bond. It requires dB is equal to 1. It will require dB is equal to at least 2. dB is equal to at least 2. It will require dB is equal to x at least 2, and it's not possible. Only A is possible. Everyone got it? Have you got it? Is it clear, kids? Is it clear? Now let's see another question. Last question. Suppose they have given C4H6O2. Possible compound or compounds. A, carboxylic acid. B, cyclic carboxylic acid. C, ester. D, unsaturated hydroxyaldehyde. E, all of these. Let's see. This compound is really awesome question. This is really going to be the genius question. Take care. No hurry, kids. No hurry. Atularu. Shruti will see everyone. No hurry. No hurry, kids. Think about it. Think about it. Kids, everyone think about it. Everyone think about it. Now see, kids, how much is the dB? Just to let me know what is the dB for it. Its dB is, degree of unsaturation is 4 plus 1 minus 6 by 2. 5 minus 3. 2. 5 minus 3 is how much, kids? 2. Now 2. Everything I think is possible. Let's see. Carboxylic acid. If I make carboxylic acid, 1, 2, 3, C double bond O, OH. Possible. And 2. So I will place here one more pi bond. If you check, you can check hydrogen automatically balanced. Now see B. Cyclic carboxylic acid. So there are 4 carbon atoms, so I will draw 3 and C double bond O, OH. Just see, 1 dB for the cycle and 1 dB for pi bond. 2 dBs are there. This is possible. Ester. So carbon, carbon, C double bond O, O, carbon. One more pi bond. This is also possible. So 3 are possible. Unsaturated hydroxyaldehyde. Unsaturated hydroxyaldehyde. I can make aldehyde. unsaturated hydroxyaldehyde. If you count hydrogen, they are automatically balanced. This is the magic. No need to balance hydrogen. Just count carbon and Dv. Hydrogens automatically balanced. Just see. If you want to check it out. 2, 1, 3. Just check. 3, 4, 2, 6. 2, 1, 3. 1, 4, 5 and 6 automatically balanced. So answer is, I hope everyone got it, kids. E is the answer. If you got it, show me green hearts. Kids, if you really got it, show me green hearts. Fast, fast, quick, 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 quick. Thank you, Shruti Vilashi. Thank you. Ha 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 ha. It was really great or not? It was awesome. Magic or not, kids? Baba has shown you the magic or not, kids? Wow. Thank you. Thank you. Thank you, kids. Thank you. And that's why I was telling you before, functional isomerism, this magic was required. This was needed. In need. It was in need. It required. Now see, kids. Functional isomerism. You can easily find out who are the functional isomers. We can say alkyne and alkene, alkyne and alkadine, because their Dv will remain same. Let me give you example. CH triple bond C, CH2, CH3 and CH2 double bond CH, CH double bond CH2. You can check it out. Their Dv is same, molecular formula is same. Only this is triple bond and that is alkadine. Now second, alcohol and ethers. Alcohol and ethers. If I talk about alcohol, for example, CH3, CH2OH, CH3O, CH3. This is ether, this is alcohol. You can see, check it out, right? Third one, alcohol and phenol. Alcohol and phenol. Can you see the difference in between alcohol and phenol? If I say this is benzyl alcohol and this is cresol, that is alcohol and phenol. What is the difference between alcohol and phenol? You can check it out. When any OH is attached with sp3 hybridized carbon, it is basic in nature, will turn red litmus blue. And when it is attached with sp2 hybridized, it is phenol. So alcohol and phenol, they are functional isomers. Now see the fourth one. You are getting it or not, kids? Everyone, are you getting it or not? Just to let me know, kids. Is it clear or not? Getting clear? Keep on showing green hearts if it is being clear, kids. I can increase the speed anytime, but kids, the most important thing is your understanding. Understanding will be there. It must be there, kids. Fourth, carboxylic acid. Carboxylic acid and carboxylic acid and just to let me know, carboxylic acid and so carboxylic acid and ester. Just see how I am writing. I am writing all these things on the basis of the basis double bond equivalent. No need to cram it. Cramming is not required. The basis double bond equivalent. How to do it? See, kids. Suppose if somebody has given me C5 and H10O2. Now my base is double bond equivalent. Double bond dB is how much? Degree of unsaturation is 1. Now what I will do? I will do 1, 2, 3, 4, 5. I will write like this. I have consumed 1 dB. Ester 1, 2, 3. I can write like this 4 and 5. 1, 2, 3, 4, 5. Now hydrogen will get balanced automatically. Just see. I have taken 1 dB. I have taken care of 1 dB. 1 dB, 1 dB is common. Hydrogen automatically balanced. Just see. CH3, CH2, CH2, CH2. Just check it out. 3 to 5 to 7 and to 9 and 10. CH3, CH2, CH2, CH3. Hydrogens are automatically balanced. Both are having the same formula. See kids, one is acid, one is ester. Now fifth one. Carboxylic acid and hydroxy aldehyde. Now check what I have to make possible thing is that carboxylic acid 1, 2, 3, 4, 5 dB1, that's clear. And this hydroxyaldehyde 1, 2, 3, 4, 5 double bond OH. What I have to think about? I have to take care of atoms and dB. Hydrogens will get automatically balanced. If you want to check it out, you can check it out. Just see. Gets CH3, CH2, 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 CH3, CH2, CH2. Just check it out. I'm not going to check. You can check it out. What I'm saying, it's automatically correct. Now, fifth number of isomers. I have told you what I am saying. Fifth. Remember that all tautomers I will teach after GOC. All tautomers are functional isomers. Sixth, all RCI ring chain isomers are functional isomers. Seventh, 1 degree, 2 degree and 3 degree amides, as well as 1 degree, 2 degree, 3 degree amines are functional isomers, right? So these are functional isomers. Now if I talk about ninth, cyanide and isocyanides are functional isomers, For example, CH3CN and CH3NC, they are being functional isomers. So 9, 10th, nitro and nitrite are functional isomers. For example, if I write down CH3, CH2NO2 and CH3, CH2O and double bond O. This is nitrito, that is nitro. They are functional isomers. I hope that is clear to all of you, my dear students. Till now it's clear. Now, metamerism. Metamerism gets compounds having same functional group but different alkyl, at least on one side of polyvalent functional group Now, this is the definition for metamerism. Till now, if everything is clear, let me see in chat section what's going on. Continuously, oh my god, continuously green hearts going on. Why, kids? Why? Great. Continuously green hearts are going on, kids. Why? What happened, kids? What happened? Wow. Feeling accomplished. Oh, able to understand everything. That's why. Oh my god, great kids, great. Wow, kids, wow. Really feeling accomplished because of Baba's happiness, Abhinya. Oh my god, great kids, wow. Baba is really feeling happy. Now, one thing we have to understand polyvalent functional group, right? Now let's see, kids. Monovalent polyvalent functional groups. RCOOH. This is example of monovalent, means only one side can be added, can never show, can't show. Polyvalent may show. These can't show. These two can't show, they may show. I will tell you why may show and why can't show. They can't show. This polyvalent is R, C double bond O, O R dash, two sides of valency, so it can show. RCOH, ROH can't show. RNH2 can't show. Aldehyde can't show. They can never show. These ether may show. 2-degree amine may show. 3-degree amine may show. Ketones may show. So these side can show. It is having 2 valency, 3 valencies. So polyvalent, all these are polyvalent, right? Let's see. For example, if I talk about formula given is C4H10N. Now, it will have total 3 metamers. Now, what are these 3 metamers? Let's see, kids. What are these 3 metamers? If I take, this is 2-degree amine, one side there is ethyl, another side also there is ethyl. Now NH functional group should remain 2-degree amine. Now see, if I put here methyl in place of there, it was ethyl. Here also it was ethyl. Now here is methyl, so there is N-propyl. So just see, on both the side it got changed. This is being methyl, that is being N-propyl. So they are metamer. If I say this is X, this is Y, so X and Y are metamers. But remember, At the same time, they are chain isomers also. See, here the parent chain is of 2 carbon atoms. Here the parent chain is of 3 carbon atoms. Can you see? They are metamers as well as chain isomers. Metamers as well as chain isomers. But if we want to select one, then write your famous position. What was that? Write your famous position. So write your famous position says who is more important. Write your famous position. Who is more important? Who is being more important, kids? Definitely metamers here and chain here. So metamer is more important. One more, let me draw. NH. So let me write down, this is isopropyl and this is being methyl, this is being methyl. So see, methyl is remaining constant, no problem. But I said at least on one side it should get changed, that is isopropyl. It got changed or not? Isopropyl. And now see kids, 1, 2, 3. If I compare X, Y, this is Z, then Y and Z are, chain is same, Y and Z are position isomers. So metamers are always either chain isomer or position isomer, but who is having more preference? Metamerism is having more preference than chain and position. If it is clear, oh my god, once again continuous green hearts. Oh my god, great kids. Oh ho ho, wow wow wow, great kids. You made my day, you made my day, kids. These are the true learners. Sahana, Prama, Avinya. Now, in structural isomerism, only tautomerism is left. But tautomerism we will study after GOC. Then only we can understand. So let's move towards stereoisomerism, okay? So now we are going to deal with the stereoisomerism, kids. Wow, great kids, great. Now let's set go towards stereoisomerism. Let's set go towards stereoisomerism. Everyone ready for the stereoisomerism? Let's set go for stereoisomerism. Very important, kids. The stereoisomerism part is being very important. I hope that everyone is ready and everyone is going to enjoy it, kids. Everyone? Okay. Now in the stereoisomerism, first of all we will deal with geometrical isomerism. Geometrical isomerism. So to show geometrical isomerism, how many types of compounds are required? Alkene can show geometrical isomerism. Cycloalkenes can show. Substituted cycloalkanes can show allene can show, spirane can show, oximo can show, aja can show. These many compounds can show what? These many compounds can show geometrical isomerism. People generally, they have thought process like only alkenes can show. They go with that only alkene can show, but these many compounds are there. Those compounds and these compounds can show geometrical isomerism, right? Let's see, kids, what is required. So if I talk about stereoisomerism, if I talk about stereoisomerism, if I talk about kids stereoisomerism, and that to GI, now kids, first of all, see, if I talk about this is carbon and carbon, first of all, remember that this is sp2 hybridized carbon and this is sp2 hybridized carbon. Each sp2 hybridized carbon must be attached. If I talk about this, if it is attached with Ramu, then this should never be Ramu, never be Ramu. It can be Champa, it can be anyone, but required thing, they should be different. They shouldn't be same. They should be different. If I say here, if there is Ramu, here Ramu is possible. Not necessary Ramu should be there. Maybe Ramu, Shamu, Champa. If Ramu, here should not be Ramu. If it is Ramu, can't show. It can be, it's not necessary Champa, it can be Alia, or it can be Champa, or it can be Shamu, or it can be Pushpa. It can be anything, but they should be different. They should be different. This is the required condition, that each sp2 hybridized, each sp2 hybridized carbon must be attached with different atom or groups, different atom or groups. This is clear. Let me make it more clear, kids. Wow, let me make it more clear. See, if I say that carbon double bond carbon, if here is hydrogen, here is hydrogen, don't see for that. It can't show. It can't show. Can never show. Anything here, doesn't matter. If I say Here is hydrogen, here is chlorine, then I have to check it out, this one also. Here is methyl, here is also methyl. They are same? Can't show, can never show. If I check it out, here is here is a Ramu, here is a Alia, here is Kalia, here is Talia. Now all they are different, will definitely it will show. Now if say here is a hydrogen, here is chlorine, here is chlorine, here is hydrogen, they are different. Different means these two are different and these two are different. So definitely 100% it will show GI. Now are you getting my point, everyone? So I would like to say which will not show GI, its double bond is dead to show GI. Dead. It's dead to show GI. It's not a stereocenter, but these two are stereocenters, means active double bonds, means active to show GI, and the one who is being active will be known as N. N is 1, N is 1, and for them N is 1. One stereocenter here also, N is equal to 1. These are being stereocenters, and there are no stereocenters. Are you getting my point? Oh my God, so many hearts and fires. Dolu bolu, dolu bolu. I will deal with dolu bolu also. But till now it's clear, kids. Wow, continuous green hearts. Wow. Kids, you are liking this much, liking, kids, you could have called your friends also. One friends, they will make 100. If you going to call one your friends or sahelis or whatever, then it will become 100. Now remember that if I say that the compound is being given like this, C H CH3 H CH3. Now in this compound you can see this is hydrogen and this is hydrogen, these are same, so they called it cis. So its GI will be like this, C. If I say there is hydrogen CH3, now see kids, hydrogen and hydrogen, they are opposite, so trans. So remember that its name is cis, its name is trans, just like one girl's. Now let me tell you, father's name is, Mr. Father is Butuin. This is father's name, Butuin, and this father is having two daughters. This father is having two daughters. One daughter's name is cis, another daughter's name is trans. This is one daughter, its name is cis, another daughter's name is trans. So they are sisters, cis and trans. There's a name, cis and trans, the name, and the relation between cis and trans, they are sisters. Just like this in chemistry, this is the father and two sisters, they are GI of each other. Two sisters are GI. GI is the relation like sisters. Clear? So GI is not the name, GI is the relation. Number of times people are thinking cis and trans like relation. No, cis and trans are the names and GI is the relation like sisters. Clear, kids? Is it clear? Till now it's clear. Okay. Now kids, if I say that if compound is given like this, C double bond C can you see anyone same out of these four? Is there anyone same out of these four? Is any one same? No. So we will say, will show GI but cis trans not defined. But cis trans not defined. Suppose two sisters are there, but they have not their names. They have forgotten their names. Now they are sisters or not? Yeah. If two persons are there which holds a relation that they are sisters, their father is common, so they are sisters, although their name is not defined. Are you getting my point? So it will show E and Z GI. Which type of geometrical isomerism it will show? It will show E and Z type. Will show E and Z geometrical isomerism, right? I hope this is clear to all of you kids. Is it clear? Just do let me know. Everyone do let me know, kids. Now, so first of all, let me tell you E and Z type geometrical isomerism. Kids, Baba is slow or Baba is teaching you up to the mark? Baba is moving with the accuracy. First of all, do let me know, kids. Baba is slow or Baba is telling you each and everything up to the mark with the accuracy, kids? Thank you, kids. Thank you, my dear students. Thank you. Everything is perfect. Now, E and Z. Rules for E and Z, but let me tell you, my dear students, if I say C double bond C, if something is attached like this, and if I say that here it is A and B, and here it is X and Y, and if I say that if B is senior, this is junior definitely, and if I say Y is senior, this is junior definitely. Now if you see, kids, that senior and senior, they are on the same side. If senior and senior are same side, it is known as Jodi. Jodi means same side. Z. Z, this is Z isomer. And if I say they are getting exchanged like this, C double bond C, here is A, here is B, here is X, here is Y, just C. This is senior, that is senior, then this is enemy, they have become enemy, so E. Otherwise, the full form of Z is Jusamen, that means on same side, and E is antigagon. But you can take it as like enemy and jet. Now, only thing is left, how to find out who is senior, who is junior. Only one thing is left, how to find out senior and junior. For that, seniority and juniority is decided by 3 scientists. Seniority is determined by three scientists. Scientist number 1, Kahan in gold. Second number in gold. Third number Prelog. This is known as CIP rule. You must have heard about CIP rule. Have you heard? CIP rule. So we are going to deal with CIP rule. CIP rule number 1. Atom with maximum atomic number will be senior most. Which atom we have to see? Atom directly attached to olefinic carbon. Which atom we have to see? Atom which is directly attached to olefinic carbon, and no need to remember the atomic number. Just you have the knowledge of periodic table. On moving from left to right, atomic number increases, and going down the group, atomic number increases. For example, if I talk about compound like this, fluorine, hydrogen, chlorine, hydrogen. Just see. Out of fluorine and hydrogen, whose atomic number is more? Fluorine's atomic number is more, so this is senior. Out of chlorine and hydrogen, whose atomic number is more? Chlorine's atomic number is more, so this is senior. Now, senior and senior are same side, so this is Z. As well as you can see, hydrogen and hydrogen are same, so Z as well as cis. One compound, but two names. One compound can have two names or not? Yes. So its GI will be like this. C double bond C. Fluorine, hydrogen, hydrogen, chlorine. Now see who is senior? Senior. So E as well as trans. One compound, two names. First CIP rule is clear. Let me give you one more example if it is not clear. If it is not clear, let me give you one more example. C double bond C. If I write down CH3, hydrogen. If I write down chlorine, bromine. Now what will you say? So if you just compare, whenever you are comparing, just see on the same carbon. Once you are going to decide seniority, just focus on one carbon. Who's senior? Carbon is senior. Carbon. Now come to this lower one. Now compare these two. sp2. These two are attached. This is senior. So senior, senior opposite. So this is E form. Is it clear? Do let me know. Is it clear, kids? Clear to each and every one, kids? Till now, is it clear? Thank you, Ninja. Thank you. Now, let's deal with CIP rule number 2. Are you ready for CIP rule number 2? Just see. When first atom is not able to decide then see the second atom for seniority, right? Now how will you see it? Just see, it's very, very important one. If I write down compound like this, now see on the left hand side sp2 hybridized, one is fluorine. Don't see bromine. Directly attached is fluorine and directly attached is carbon. Who is senior? Don't go for bromine. Don't see bromine. This is senior. Now this is senior. So senior and senior opposite. So E. Let me give you one for you, kids. Just try it out. E or Z? Do let me know, E or Z. Let's see, kids. How many of you are able to do it? How many of you are going to give the correct answer? Maximum people are going for E. Some are going for Z. Oh my God. Both the two types of answers are coming out. No, 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 kids. No, 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 no. What are you doing, kids? So I have to interfere into this. Kids, do it clearly. What is this? Let's see. This is sp2 hybridized carbon. Am I right? Now this is saying carbon. I am attached is carbon. This is chlorine. So this is senior. Don't see iodine. The first atom. First compare the first. This is senior. Here this is saying I am carbon. I am carbon. So its senior is oxygen. Its senior is bromine. Out of oxygen and bromine, who is senior? Bromine is senior. So senior Z. Got it? Let me check it out. This time, kids, you got stuck. You got stuck, got negative marks, some of you. Everyone, is it clear or not, kids? Do let me know. Everyone, CIP rule number 2 is clear or not? Got it. Okay, Avinya, let me tell you. Avinya, just see. This is carbon. Just see, fluorine is attached. The first atom is fluorine. Here the first atom is carbon. Out of fluorine and carbon, who is senior? Fluorine. First atom, okay? First atom. Decided? They are not same. Now first atom, chlorine and iodine, senior. Oh, E, senior is this side and one senior this side, opposite E. Now see here, this is carbon, first atom carbon, so tie is there. Now he is saying my senior is oxygen, my senior is bromine, so bromine is senior than oxygen, so senior. Now here see, the first atom is carbon and first atom is chlorine, so first atom has decided that this is senior. Now senior same side. Now clear? If not clear, I will explain again. If it is not clear, I will explain again. Just do let me know. Avinya? Now say, Avinya, if not clear, then I will explain again. Don't worry. Okay, clear. Now let me give you one more question. So that let me check it out. Do let me know. I'm waiting for your answer. Do let me know. E or Z? Razer MU is going for Z. Oh my god, Monica is going for E. Now rest are going for Z. Let me check it out. Who is going to be the winner? Shruti Blessy is going for Z. Everyone is going. Oh, Anna Purreddy, Deepu is going for E. Kids, one type of answer. I need one type of answer. Now let me check it out. I have to give the correct answer. Now see, kids. sp2 hybridized. This is CH2. This is CH2. Tie. Now this is oxygen. This is nitrogen. Who is senior out of oxygen and nitrogen? Oxygen is senior. So this group has become senior, right? Now come over here. Carbon, first atom is carbon, first atom is oxygen. Who is senior? Carbon and oxygen. Carbon 6, oxygen is 8 atomic number. Oxygen is senior. So that is on this side, this is on this side. Everyone got failed. It is E. Should I tell you what mistake you have done? You have considered it to COH and you have applied IUPAC. You have considered it to COH and applied IUPAC. Am I right? This mistake is being done by you. You kids have done this mistake or not? Kids, you have done this mistake or not? Tell me. Don't see the functional group. Apply CIP rule. So, what lesson you got? Moral of the story. Lesson Remember, point to be noted, my lord. Apply CIP. Don't apply IUPAC. Don't see the group, just see atoms individually. Apply CIP rule. Warning, warning, warning. Public में जा रही, warning. How to make it, I don't know. Khopadia like this, warning. It's like this or something else. Warning. Kids got it? Okay, Shruti Bisley, don't worry. Let me give you more questions. Don't worry. Let me give you one more. Do not worry, kids. Don't worry. I will make it clear. Don't worry. I will make it clear. Now, do it. E or Z? E for enemy. E for enemy, opposite side. E for enemy, opposite. Z for same. Jodi, Jodi. Two kids are going for E, rest are going for Z. Two kids are going for E, rest are going for Z. Now let me check it out. Remember that whenever you are comparing senior and junior, just see on same carbon, two attached on the same carbon. Now see, move atom by atom. Carbon. This is saying I'm carbon. This is saying I'm also carbon. Carbon, carbon tie. Now see the second atom. Oxygen. He is saying, oh, carbon. So who is winner? Carbon, carbon. Second also senior carbon, but second is oxygen. Who is winner? Oxygen is winner. So this is senior. Now leave that, come to this. Now forget about that. Out of this is saying carbon. This is saying nitrogen. This is saying A. I am attached with bromine. This carbon is saying A. Don't shout. Don't see bromine. Just first see this is nitrogen. This is carbon. Just see yourself. Who is senior? Talking about bromine. Don't talk about bromine. Bromine is attached to. So nitrogen is senior. So senior. Now senior and senior, they are on same side. Senior. So they are same side. Senior, same side. So we will say Z configuration. Got it, kids? Everyone, is it clear? Just to let me know in the chat section. Is it clear to each and everyone? It has become clear to each and everyone. Congratulations. Everyone got it, kids. Now nothing is tough. Once you resolve upon doing, all the obstacles in your path will disappear and the means to its achievement will appear in front of you. So keep on doing, keep on learning. Now, CIP rule number 3. Now Baba is going to deal with CIP rule number 3. Just see, guys. In case of isotopes, more the mass, more will be seniority. For example, tritium 1,3, deuterium 1,2, protium 1,1, right? Or if I say carbon 614, carbon 613, carbon 612, like this. So if I give you question like this, simply if it is written like this, just see kids, deuterium and hydrogen, deuterium is senior and carbon CS3, that means it is 12 understood and 14 this is senior. So Z configuration, is it clear? Now CIP rule number 4 is a little bit tough. CIP rule number 4 is a little bit tough. Till now it's clear, so I will move with CIP rule number 4. Focus over here. In case of multiple bonds, we have to draw hypothetical structures. Now kids, hypothetical structures we cannot draw like any hypothesis. We cannot apply any hypothesis. I will let you know, and you have to do like that. Okay. Now suppose if I say that I am being provided with CHO. Now I should be able to write down CHO properly. How I will write? CH double bond O. So till now it's okay. Now I will draw hypothetical structure. See how to draw it. Whatever the number of sigma bonds are there, draw it like this. Just I have to break the pi bond. See. Sigma bonds I have drawn like this. Whatever the sigma bonds were present, I have drawn. Right, kids? I have drawn sigma bond as such. Now, who has been broken up? Carbon was attached to pi bond and oxygen. So, I have broken up their bond. Now, media person has come. And media started asking, hey, what happened over here? Carbon started trying. My pi bond has been broken. Hey, carbon, your pi bond was attached with whom? Sir, I was attached with oxygen. Okay, don't worry. Take oxygen. Now oxygen started crying. Help me, help me, help me. Hey, oxygen, what has happened? My pi bond has been broken. Hey, oxygen, your pi bond was attached with whom? Carbon. So take carbon. Say, this is hypothetical structure. Got it? This is hypothetical structure. So hypothetical structure says it was this carbon was looking like attached with one oxygen, but actually the carbon is attached with how many oxygens? 1, and 2 oxygens. It was looking like attached with 1 oxygen, but it is actually attached with 2 oxygen. Kids got it? If not, then I will make 1 or 2 more structures. Don't worry, I will make 3, 4, 5, 6 structures if it is not clear. Okay, let me draw more structures. Don't worry. I will explain it again. Let me take fresh page. Let me compare with CH2OH, CHO, and COOH, right? So my duty is to first write down their valency wise structure, and then I will draw hypothetical structure. Okay, just see. So this is having all sigma bonds only, so no problem, right? Its hypothetical structure will be like this only. It is same, it will remain same. But this one, just see, CH double bond O. Right now I have broken and drawn like this. See, already I have told you. It was... Okay, now this one. It is attached with 1 pi bond. This is pi bond. So sigma bonds will remain like this. Only which bond I will break? Pi bond. So this pi bond has broken up. Now they have started crying because their pi bond has been broken up. This carbon was attached with through pi bond oxygen. So I have given oxygen to this. This oxygen was attached with carbon. I have given carbon, right? Now see who is senior most. Carbon, carbon, tie. All 3 are carbon, right? Now see. This carbon is attached with 1 oxygen, this carbon is attached with 1, 2 oxygen, and this carbon is attached with 1, 2, 3 oxygen. So the seniority order is like this. Got it? This is the seniority. This is most senior most. This is senior most. This is junior most. Now, if it is like this, if you got this much, how to write down the hypothetical structure, then you can compare and you can find out E and Z. See, if anyone is going to give you compound like this, now tell me E or Z, if you can compare, just to let me know E or Z. Kids, do let me know. Wow, Subhra Datta, all the best. God bless you with maximum marks, Subhra Datta. May Almighty God bless you with the best. Karthik, yes, going for E. Shruti Vilasi is going for Z. Razur Mu is going for Z. Deepu is going with Z. Maximum people are going for Z. Let me see to it. This is looking like with 2 oxygen, but actually attached with 3 oxygens. If you draw its hypothetical structure, it is looking like 1 but attached with 2 oxygen atoms, right? So who is senior? Upper one is senior, this is senior, right? Now here it is attached with 1 oxygen. C is common, 1 oxygen, and it is hypothetical 2 oxygens, right? If you draw its hypothetical, then 2 oxygens. So this is senior, same side, so Z configuration, and this is CHO and CHO. With that respect, it is trans also, Z as well as trans. Got it, kids? Everyone, is it clear? Is it clear, kids? Do let me know. Now one question, let me give you one question, kids. Tell me E or Z? E or Z? EZ. Now see, kids, this is saying I am carbon, and its senior most it's oxygen. This is carbon and senior most are also carbon, so that is senior. Oxygen is winner. But here see, carbon same, sex is oxygen, next is carbon and carbon only, so this is senior. So senior same side, so it is Z configuration. Got it, kids? How many of you got it? Just to let me know in the chat section, kids. How many of you got it? Let me see in the chat section that how many of you got it. Now, kids, E and Z is clear. We'll meet after a short break with rest of GI part, right? So, break. Let's meet at 5:35, right, kids? Come with full of ATPs, come with full on energy, kids, come with lots of energy, kids. Okay, kids, will you come with lot of energy, kids? Because lot of energy is required to understand. Do let me know. Make a promise, kids, make a promise. Shruti Blishi, after isomerism, I will start GOC. Shruti Blishi, after, yeah, I will complete with each and everything. I will cover up Tamil Nadu board also. Don't worry if today the whole 11th NCERT is not covered up. I'm not going to skip even a single thing. I will keep on writing on the blank page I will teach each and everything in detail, kids. If anything is left, because everything should not be able to, I will not be able to complete. Will not be able to complete means I don't think hydrocarbon and purification of organic compound today we will complete, kids. But don't worry, I will take second part of it. But I'm not going to skip even a single thing. Remember that. Increasing speed, skipping number of things, what does it mean? How you will get selected? I will teach you in such a way that I will cover up each and everything. Whatever is missing in Tamil Nadu board NCERT, I will cover up. Whatever is missing in NCERT, I will let you know. I will tell you each and everything. Is that clear, kids? And tell your friends, tell your all the friends that Baba is not skipping even a single thing. Not even a single thing. You must have seen, kids. I'm not skipping even a single thing. I'm telling you each and everything. So we have to go inch by inch, step by step, words by words. I will let you know each and everything, right, kids? Welcome back again, kids. Just yes, do let me know with the fire in the chat section that everyone back. Are you ready, kids? So stereoisomers, that is GIE and GI. GIE. So CIP rule already I have told you. Show me green hearts along with fire in the chat section so that I can understand that everyone is ready, kids. Fast, 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 kids, fast. Now, calculation of Tangi. Calculation of Tangi. TNGI. What is the full form of Tangi? Tangi is total number of geometrical isomers. Now, how to find out total number of geometrical isomers? That is most important thing. Now, I'm going to give you table for this. Remember that case number 1. Case number 1. Okay, let me write down the formula for this Tangi. Okay, let me write down here the formula for this. So, for Tangi, total number of geometrical isomers. Okay. Now, case number 1. When terminal atoms or groups, when are different. Case number 1 are different, right? Are different. Then, and remember that n is equal to even or odd. What is n? What is n? N can be even or odd. N is equal to total number of active double bonds. Active double bonds I have told you, kids. Total number of active double bonds. Are you getting my point, kids? Everyone, are you getting my point? Now, in this case, Tangi will be equal to 2 raised to power n. 2 raised to power n. I will explain. But first of all, let me write down the formula. Now, case number 2, kids. Case number 2. When terminal atoms or groups are same. Now, Tangi will be equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now, 2 raised to power n minus 1, 2 raised to power p minus 1. What is this, kids? What is the meaning of this? Let me tell you, kids. Here, 2 subcases arises. Subcase 1, when n is equal to even and when n is equal to odd. Remember that when n is equal to even, then the value of p is equal to n plus 1 by 2 n plus 1 by 2. n, even, so n by 2, not n plus 1 by 2, n by 2, and odd in case of n, odd p is equal to n plus 1 by 2. Remember that? These are the formulas. Now, that's why I have written on single page, so that you should not get confused, kids. That's why I have written the formula on single page. I will explain it one by one. Okay, kids? Are you ready? So, one formula for that, one formula, this formula is for this one, this formula is for this one when terminal atoms or groups are different. Then even or odd, there is only one formula, but for this the formula is different. For here the one formula and here the formula is different, right? Now kids, right now see, even I have forgotten that n plus 1 here or that place. Then how I recognized, because here n is equal to even, so even will cancelled out by 2, but odd will not get cancelled out. And more than that, visualization is very important. If you don't visualize, sometimes formula will be right or wrong, so that will kill your marks. That will not give you that much satisfaction, right kids? So are you ready? Just to let me know everyone is there. Show me green hearts, everyone. Everyone, are you back? Are you back, kids? Now let me explain one by one. Let me explain one by one. Case number 1. Case number 1. Case number 1. See, kids. CH3, CH double bond CH, CH double bond CH, and C2H5. Now see, if I talk about this double bond, this sp2 hybridized carbon, it is attached with methyl and one hydrogen, right? So it's active. This carbon, hydrogen, and ethyl, this is active. Both the two double bonds are active, and it will show GI from this area to this area. That means its carbon involved to show GI are this carbons, right? These carbons are involved to show GI. Just see, this environment is involved. Now who is left? Who is left, kids? Left portion, this is R1 and that is R2. Do you think terminal atoms or groups are same? R1 is equal to R2? No, R1 is not equal to R2, and this is, so we will apply Tangi. Total number of geometrical isomers are 2 raised to power 2, 4. Now I will say, sir, this is the formula you have applied. Just let us visualize it. So see, this double bond and this double bond, 2 double bonds are there, 1 double bond, another double bond. With respect to both the double bonds, how many possibilities are there, kids? How many possibilities are there? Just see, how many possibilities are there? This can be cis, that can be cis, this can be trans, this can be trans, both can be trans, this can be cis, that is trans, this can be trans, that is cis. How many possibilities, how many permutation and combinations are there, kids? 4 possibilities are there. So this is formula wise, that is visualization. Both the part you just see, this one is visualization, kids, and this is formula. Both you can apply, it depends on you. I hope that you got it. I want to see green hearts if it is clear to each and every one, formula and visualization. Now if it would have been 3 double bonds, just see 3 double bonds, CH3, CH double bond CH, double bond CH, CH double bond CH, chlorine. Just see 3 active double bonds are there. 3 active double bonds are there. That means it will show from here to here. Now if you see R1 and R2, they are same or different. This is R1 and that is being R2. Just see, R1 and R2 are different or same, kids? Definitely this one is R1 and that is R2. They are being different. R1 is not equal to R2, right? R1 is not equal to R2. That means for total number of GIT and GI, you can apply formula 2 raised to power n and n 1, 2, 3. So 2 raised to power 3, that is equal to 8, or you can apply visualization part. So double bonds are 3, cis, 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 trans, 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 cis, cis, trans, 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 cis, cis, trans, 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 cis, 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 trans, cis, trans, cis, trans. Now it's very lengthy to write down like this: 1, 2, 3, 4, 6, 7, 8. That's why they made formula. It's easy to write down. Got it till now? It's clear, my dear students, respected students, loving students, my dear students. These are studious students. You are really studious students, and I will do each and everything for you kids. I need kids like you, Jyoti Jain, Shubhan, Hafiz, very, very, Deepu. Thank you, thank you. Now there's Jyoti Jain. Jyoti Jain got 80 out of 100 in JEE Mains. Jyoti Jain, am I right? Tell them how many marks you got out of 100 in chemistry, JEE Mains. Now, case number 2. Let's deal with case number 2, kids. Kids, just to complete each and everything within few hours, I could have escaped number of things, but I haven't escaped anything. I haven't escaped anything. Now see, kids, case number 2. CH3 subcase n is equal to 2 even. Now see, kids, it will show GI from here to here, and you can check it out. R1 and R2 are same or different. This is R1, this is R2. Can you see, kids? R1 and R2 are same. So Tanguy formula is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1. So 2 raised to power 2 minus 1 plus 2 raised to power p is equal to n by 2. So 2 by 2 minus 1. So math says 2 raised to power 1 plus 2 raised to power 1 minus 1, 0. So 2 plus 1, that is coming out total 3. Is it clear? Total 3, kids. Fine. Now if you visualize it, then you will get it with the visualization cis, cis, trans, trans. But if you talk about CT and TC, these are identical. Why these are identical, kids? Why these are identical? Because this side methyl, that side methyl, these both are same. So it's cis and that one's trans, or that trans, or this one cis. Both will be same. So 1, 2 and together counted as 3. Is it clear, kids? Do let me know, kids. Is it clear? I want to see in the chat section. Is it clear to each and everyone? Thank you, Jyoti. Thank you. Oh, 2 Jyoti are there. I was talking about Jyoti Jain and Jyoti Shanumugadarsan. I was talking about Jyoti Jain. He is Kushiga and he got 80 marks out of 100. And his NIT confirmed, he qualified for JEE Advance also, right? Now, another one, case number 2, subcase. So case number 2, subcase n is equal to odd. Now see, CH3, CH double bond CH. Now see kids, it will show GI from here to here. All three are active, 1, 2, 3, but they are odd. And this is R1 and that is R2 kids. R1 and R2 are same, both are methyl. So apply the formula total number of geometrical isomers 2 raised to power n minus 1, 2 raised to power p minus 1, 2 raised to power n minus 1, 2 raised to power n plus 1 by 2 minus 1, 2 raised to power 3 minus 1, 2 raised to power 3 plus 1 by 2 minus 1, 2 raised to power 2, 2 raised to power 3 plus 1, 4 by 2, 2 minus 1, 2 raised to power 2 is 4 plus 2, 6. Everyone, just see, check it out. Kids, just check it out. Mathematically it is right or wrong. Kids, just check it out. Mathematically it is right or wrong. Everyone got it clear? Just to let me know. Your understanding means a lot. Kids, each and everything is clear. Okay, now kids, okay, now I hope that everyone is ready for now. Let's move on. Now just see GI in allenes. GI in allenes. GI in allenes. Now remember that allene is example of cumulated system. Cumulated system. Now what do you mean by cumulated system? That means continuous double bond. Continuous double bonds. Now the smallest allene is like this. This is smallest allene, but remember that which allene will show GI. There are conditions to show GI by allenes. First condition, each sp2 hybridized carbon must be attached with different atoms or groups. And second thing is that total number of pi bonds must be odd. Must be odd. Now how will you remember these two things? When you forget these two things, so this will not show GI. It will never show GI because pi bonds are 1 and 2. So how will you remember these two things? when you are not able to understand anything, if you have forgotten each and everything, just remember one thing: God. God gets God. What do you mean by God? To show GI, number of pi bonds must be odd. To show GI, number of pi bonds must be odd. And God is also known as Allah in Aline, right? How is the trick, kids? How is the trick? Kids, how is the trick? Do let me know. Everyone just do let me know how is the trick. Good one. Now see. CH3 H CH3 H. First of all, see the hybridization kits. sp2 sp sp sp2. So see kids, which carbon we have to focus? This carbon we have to focus, this carbon we have to focus. These two carbons we have to focus. Now see on this carbon, this group and this group, they are same or different? They are being different. Now see on this hydrogen and this CH3 is same or different? Different. Got it, kids? First point is clear. Now see, number of pi bonds are 1, 2, 3. 3 odd. So it will show GI. Remember that it will show GI. But if it is even, it will never show GI. Now how many of you want to know the reason? How many of you are interested in reason? Just to let me know. How many of you are interested? How many of you are interested in reason? This is the trick I have shown you. To remember God, to show GI, it must be odd. It must be odd. How many of you want to know the reason? See the reason. Kids, if I write down like this, second, if I write down like this, third, if I write down like this, now I would like to say it will show GI. It will show GI. Both of them will show GI, but they are not optically active. Optical isomerism they will not show. Optical isomerism they will not show. But This will not show GI, it will not show GI, but it will show what? Optical isomerism it will show. Now what's the difference, kids? What's the difference? Now let's see. The difference is that if I tell you, if this is sigma bond, just focus kids, just focus. If I say this is sigma bond, this is sigma bond, the pi bond will lie perpendicular to it. Are you getting my point? And if I say this is sigma bond, then pi bond will lie perpendicular to this. If I say this is sigma bond, just see, if I make this sigma bond, then pi bond is perpendicular to this. Both are always perpendicular to each other. Can you see? This pi bond is perpendicular to this. This pi bond is this sigma bond is perpendicular to pi bond, and pi bond is perpendicular to sigma bond. Is it clear, kids? Now, if I say that suppose this is horizontal, this hydrogen is horizontal, lying towards your side, then the pi bond will go, this pi bond will go vertical, and this pi bond is going vertical and it is forming a bond with this, then both of them are vertical. This pi bond is vertical, then the sigma bond once again will come out horizontal. That means these two hydrogen are in one plane. Two hydrogens are in one plane. Two hydrogens are in one plane. Now, if you see this one, if I say this is horizontally lying, then the pi bond is going kids. Pi bond is going vertical. Am I right, kids? Pi bond is going vertical. Now, kids, one more thing. Let me tell you one more thing. If I say this is sigma, this is pi, if I make on the same carbon one more pi, then this will go like this. Can you see, kids? It will go like this. Can you see? Perpendicular to each other. That means one more pi bond will go like this. This, no, not on that. It's over here. It is having two pi bonds, so it will go horizontal. And if it is going horizontal like this, if it is going horizontal, then this sigma bond will be vertical actually. This sigma bond will be vertical. It will be lying vertically. It is not like that. This is lying vertically, kids. It's being vertical. That means this hydrogen and that hydrogen are in different plane. Two hydrogens are in different plane, so they are not in same plane. Now if I come to this place, this is horizontal, so pi bond is vertical, this pi bond is horizontal, so this pi bond is vertical, so once again this is horizontal, so both the hydrogens are in same plane. Two hydrogens are in kids. How many of you got it? The clarity, the bonding. If you want, then I can draw it. If you need, this is vertical and horizontal, then vertical. Got it, kids? How many of you got it? I have applied all the efforts to make Shruti Blissy is unable to understand. Okay, kids. Don't worry. Shruti Blissy, I will make it clear. Don't worry. Rest of others, just to let me know how many of you are getting it. Don't worry, I will make it clear. Shruti Blissy, I will make it clear. Okay, Parma, I will make it clear. Just see. Don't worry. See, let me make it clear. First, see, if I write down simple alkene, okay, simple alkene. If I say the alkene is like this, let me make one bed. Bed, you know, bed, you know, this is bed, okay. First, let me make one bed, so you can understand. Bed is always planar, that you know. Bed is planar, that you know, kids. First of all, do let me know that you people know bed is planar. Everyone, show me green arts. You know bed is planar. Now this is bed, okay, this is bed. Okay, this is bed. Clear, kids? Now, on bed, this is one carbon. This is another carbon, right? They are on bed. Carbon is spherical, going upper side of the bed, going down side of the bed, okay? Carbon, you know, carbon is spherical, going upper side of the bed and down side. This is bed, okay? Bed, this is bed. This is bed, okay? This is bed. Carbon, two carbons are there. Now, hydrogen is sleeping, and hydrogen is coming towards your side. Where the hydrogen has gone? Hydrogen is coming towards your side, kids. Hydrogen is coming towards your side, okay? He is on bed and it is coming towards your side, kids, okay? It's coming towards your side. Hydrogen is coming towards your side. He is on bed. He is sleeping on bed and he is coming towards your side. This much is clear, kids. This is hydrogen. And methyl is going away from you. He is also on bed. He is also on bed, right? Methyl is there. Now this hydrogen is coming towards your side, on the bed only, and coming towards your side, kids, right? Coming towards your side, and this methyl is going away from you, right, kids? Now, kids, can you tell me, this is sigma bond, this is sigma bond. Now pi bond will be vertical. Pi bond will be going like this. Pi bond will be going like this, above the bed and below the bed. See, one p orbital will be going like this. See, just see. P orbital should be going like this. Just see, kids. P orbital going like this. Above the bed, one lobe is going above the bed, perpendicular, and one lobe is going below the bed. Below the bed. One lobe is going below the bed. This is going below the bed. Below the bed. Here also one orbitals, one lobe is going above the bed. Above the bed means vertical. They are perpendicular to the sigma bond. It is going above the bed and this is going below the bed. Now can you understand? So we will say the bonding is, this bonding is vertical. They are vertical. That means they are vertical. Play parallel to each other but going vertical. Going vertical. Going vertical. Kids. So I will say this is on bed, so horizontal. This is on bed, so horizontal. And the pi bond is with respect to this is vertical. This is vertical. Kids. So they are on bed, same side. One, means on bed only, both the hydrogens on the bed, they are saying we are on same side. This one you got it. This one you got it or not? Do let me know this one is clear. Now let me tell you, two double bonds are there. If an allene two double bonds are there, if an allene two pi bonds are there. Now let me make bed once again, the bed. Let me make the bed. This time I will make bed of this. Okay. This is the bed. Let me make big bed this time so that everyone can understand, kids. Everyone, this is planar bed. I'm making bed, kids, right? Okay, this is bed, right, kids? Now let me put carbon. First carbon, second carbon, okay, let me copy it, kids, so that we can save our time. One carbon, second carbon, kids, and third carbon, right? Three carbons. Let me join carbon to carbon, carbon, carbon to carbon. I have joined three carbons, right, kids? Three carbons. This is carbon, this is carbon, this is carbon, this is carbon. Now once again, this is the bed, and hydrogen is lying towards your side. This hydrogen is lying towards your side, kids. This hydrogen is towards your side, okay? On the bed only, it is on bed. Bed is horizontal, horizontal. This methyl is going away from you. Now, here is one pi bond. Pi bond will be vertical. Pi bond means this lobe must be going above the plane, above the bed, and it must be going below the bed, right? That is below the bed. I'm drawing it over here, but going above the bed, below the bed. So, blood, not blood, bed. Okay, it is going above the bed and below the bed, right? Now, kids, if I say it is horizontal, then this will be vertical, perpendicular to the plane of paper, plane of bed, vertical, vertical. Now it is having one more pi bond, that must be going like this. That pi bond must be going like this, kids. Horizontal, perpendicular to that. Now see, kids, it must be going horizontal, right? On the bed, it is on the bed. It is on the bed. So it is horizontal, kids. Now if it is horizontal, then the sigma bond will be perpendicular to this pi bond. So it must be going like this. That means one hydrogen atom is going above and one hydrogen is going below the bed. Now this hydrogen is going above the bed, above bed, or we can say it is vertical. It is vertical. So this hydrogen and this hydrogen, they are not in same plane. Just check it out now, kids. Everyone now check it out. So the two hydrogens, they are not in same plane. One hydrogen is horizontal, another hydrogen is vertical. This is vertical, means above the bed, and this is horizontal, means on the bed. Got it, kids? Now, if I take 3 pi bonds, then see 1, 2, 3 and 4 carbons. 1, 2, 3, 4 carbons. Now once again I will draw. This is hydrogen coming towards observer side, means on the bed. This hydrogen is on the bed. Okay, kids? This hydrogen is on the bed. On the bed, horizontal. Methyl is on the bed, horizontal. Then the pi bond will be, kids, do let me know, pi bond will be going above and below. That means vertical. Pi bond will be, kids, pi bond will be vertical. One pi bond is vertical, then another one will be horizontal. Am I right, kids? Horizontal, then another pi bond will be vertical. Above and below the bed. Now this pi bond is vertical, then the sigma bond will be horizontal. So this will come on the bed. Now these two hydrogens, this is horizontal, this is horizontal. Two hydrogens are in the same plane or different planes. So we'll show GI, because two hydrogens are in the same plane. Two hydrogens are in the same plane. Now kids, just try to understand. You got it? Shruti, Blessy, you got it? Now, Abhinya, Prama, Parama, everyone clear, kids? How you are feeling now? How are you feeling now? Everyone got it? Kids, smash the like button. Thank you, Shruti, Blessy. Thank you. Now, kids, let's move ahead. So this much is clear. Now let me show you something. GI in substituted cycloalkanes. Now see, kids, if I draw one compound like this, now see, kids, if I write down compounds like this, just see kids, one chlorine is going upside, hydrogen is going downside, one chlorine is going upside, hydrogen is going downside. Up and up, they are on same side or different side kids? So two chlorines are on same side, so we will say it's being cis, it is cis form, and one chlorine is going up and one chlorine is going down. What do you call it kids? One is going up, one is going down. This is going up, this is going down. So opposite side we will say trans. So the relation in between these two will be they are GI of each other. GI, kids, got it? They are GI. They are GI. Now if I write down like this, if I draw one chlorine at this place, one chlorine at this place, then also I can say the upside and this downside. Just see their position remaining same. This is at 1 and 4. That is also at 1 and 4. Now see to it, this is going up and this is going up. So cis, and this is going up and this is going down. So it is trans. They are also GI. Is it clear kids? Is this much clear? Then I will tell you it's rank deciding one. Rank deciding also I will tell you. But first of all, do let me know till now it is clear to all of you. Till now it is clear. Very good. Now, let me tell you it's rank deciding one, right? Now, let me show you its rank deciding one. Rank deciding, right? Rank deciding. This you have to prepare only if you are getting more than 650 marks. That is 650 marks. If your marks are more than 650, don't only go for this. Otherwise, leave it, right? Now, see kids. If I make chair form you know, just try to see. I am going to make chair form. Chair form. How to draw it? Once again, let me tell you kids. Now, this is the chair form. Can you see clearly kids? It's being the chair form. Is it visible to all of you? In this chair form, how many rockets are going up? Can you tell me how many rockets are going up? The rockets which are going up, let me point with the orange one. See, these are the 3 rockets going up and 3 rockets are going down. See, these are 3 going down. Can you see kids? This much can you visualize? 3 are going up and 3 are going down. Okay, this much is clear to all of you. 3 are going up, 3 are going down. Now, let me write down so that you can find out. This is going up, 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 and these are going down, 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 and down. Got it? Now the second point, the tetrahedral visualization is very, very important. If I say this is 1V, this is 1V, tetrahedral visualization is very important. then another V will go like this, bisecting it. Now if I say this is one V, then if this V, this rocket is going up, just try to understand. If I say this rocket is going up, if this rocket is going up, then at the tip of this rocket, another V will go like upside, and this upper side will be known as axial and another one equatorial. Not able to understand? No problem. Let me tell you over here. This rocket is going up. If rocket is going up, then the bond which is going up will be known as axial and another one will be known as equatorial. Another one will be known as equatorial. This one will be known as equatorial. So if I say, if here I place CH3, so the rocket is going up, so this is also going up, and this one is axial. Just try to understand. Forget about equatorial. If rocket is going up, axial will go up, and if rocket is going down, I will tell you. If rocket is going up, axial will go up, then equatorial will go down. Forget about equatorial. I think you are confused. You got confused? Don't worry, don't worry. Let me tell you something. Let me tell you something. Remember that rocket up, axial also up. Rocket down, axial down. Now is it okay? This much you can remember. Rocket up, axial up, rocket down, axial down. Kids, this much can you remember? Now see, this is the rocket up, so its axial will be up, equatorial will be down. Rocket up, so axial is up, this is axial is up. Now rocket down, so axial will be down. Axial down, so equatorial up. Now this axial is up, this methyl is up, and that methyl is down. One is up, one is down, so they are on opposite side. Two methyls are opposite side, so cis or trans? Tell me, kids. If you got it, then also fine. Not got it, then also fine. I will explain once again. Kids, got it? Okay. Now if you got it, now let me show you its cis and trans. Just see, kids. Let me show you the cis and trans. Just see. If I draw this one as, and second one, this is the first one. Okay. So in this, if I place methyl over here, hydrogen over here, methyl over here, hydrogen over here, and let me make another compound like this. Now see, kids. Now if I place one at this place, one at this place, one at this place, one at this place, and try to understand, this is going to be the rank deciding, kids. This is going to be the rank deciding. Just see, if I place methyl at axial position and this methyl at equatorial position, and here if I place both the methyl at axial position, now just to let me know, kids, is there any relation in between these two? First one form is what? Cis or trans? Just to let me know, this form is being cis or trans. Now try to understand, rocket is going up, so axial is going up, methyl is up, rocket is going down, so axial is going down, and if it is going down, then equatorial is up. So this methyl is up, this methyl is up, so I would like to say this is cis form. And here the rocket is going up, so axial is going up, and this rocket is going down, so axial is going down. So up and down, they are opposite, so trans, one cis, one trans, they are GI. So 1 and 2 are GI. Kids, this is rank deciding question. If you're getting more than 650 marks, then only go for this. Otherwise, you can skip it. How many of you got it? Show me the green hearts. Kids, this is going to be the rank deciding. Very good, kids, very good. Now, very good. Now let's go with GI in alkenes. Now you got it that, kids, Baba is not leaving even a single thing. You got it that Baba is not leaving even a single thing. Baba is covering up each and everything, kids. Baba is not leaving a single concept. Now GI in cycloalkenes. Now remember that cycloalkenes up to 7-membered remains only in their cis form, remain only in cis form. They do not have their trans form. Due to angle strain. Therefore, do not show GI. With respect to double bond. Now, what is the meaning of this double bond? First of all, see this and let me explain this. That if I write down, kids, if I write down cyclobutene, if I write down cyclopropene, then they will exist in their cis form. This bond, this is sp2 hybridized, this is going toward this side, so hydrogen toward this side, hydrogen toward this side. This is cis form. Here also if I place double bond, so hydrogen this side, cis form. Even if I place cyclohexene, then hydrogen going this side, cis form. They do not have their trans form. Trans form starts from 8-membered cycloalkene. Trans form starts from 8-membered cyclohexene. Just like, for example, if I write down cyclooctatetraene, then cyclooctatetraene is like this. The cis form also exists and its trans form also exists. Just see kids, its trans form also exists. Now see how to find out trans. This bond is going toward this side, so hydrogen will be toward this side. This is going toward this side, so its hydrogen will be this side. So they are opposite sides. So this is trans. Now how is it possible this is cis? Because number of carbons increased. If I say, if you touch your body like front side, you can touch, but if you try to touch from back side, you won't be able to touch. But if your length is getting increased, you will be able to touch from the front side as well as back side. Now what is the meaning of that? It will not show GI with respect to double bond. I must have written somewhere that it will not show GI with respect to double bond. What is the meaning of this word? They will ask one question from here. Just see how they can ask and what type of questions they can ask it. See, let me show you what type of questions they can ask in the examination. One question which will show GI. Question is, which will show GI. Now options are I'm waiting for your answer. Just do let me know what's your answer, kids. Yes, everyone. Kotini, Ravi Kumar 4, Annapurna Deepu all, Shirisha D. Okay, so let me declare the answer. The answer is being kids D. Now see why D. This will exist in cis form, can't show, cis form can't show, and this is in cis form, can't show, but this is dead. See, here it is dead, here it is dead, can't show GI, here it is dead, can't show GI, here this is dead, can't show GI. Then from where it has shown GI? It has shown GI from here. Just see, it will exist in two forms. What are these two forms? Now see kids, double bond, once methyl up, hydrogen down, methyl up, hydrogen down, cis form, once methyl up, hydrogen down, hydrogen up, methyl down. So these are two GI. It has shown GI with respect to these two methyls. Got it or not? Double bond is not showing, but you see here two methyls are on the same side, but here this is up, this is down. Got it? Clear, kids? Is it clear? Just to let me know in the chat section. It is clear, kids? So this is all about geometrical isomerism. Now one stereocenter, there is one stereocenter. Now I will ask one tough question. One tough question. Let me take one tough question, kids. Tough question. They see from GI, tough question. If I take question like this, see kids, total number of GI shown by this compound. Rank deciding question, kids. Now total number of GI shown by this compound. This is the question. Tell me. Tell me kids. What's your idea? So definitely just see from here to here continuous pi bonds are there. 1 pi bond, 2 pi bond, 3 pi bond. So this is cumulated system, right? That means it is allene, and an allene, what is required? This must be different with this. So they are different, sp2, and they are different, and it is odd. So this is one stereocenter. From here to here, this is one stereocenter, that is allene, and that is another one stereocenter. See, sp2, this is simple alkene, this is another stereocenter. This is being simple. So one, and this is second one, this is second one. So there is 1 and 1. So the value of n is coming out 1 plus 1, that is 2. So 2 raised to power. So 2 raised to power 2, that is 4 is the answer. 4 GI. Got it, kids? Kids, is it clear? Just to let me know. This is a rank deciding question. Now another question like this, another question I am going to deal with. If it is clear, show me green heart so that I can understand that it's been clear to each and every one of you. Now, very good. Another question. See, if they are going to ask question like this, CH3, CH double bond CH, CH double bond CH, CH double bond CH2. Once again, total number of geometrical isomers. So remember that, kids. You can see it's not allene. This is active. This is active. And you see this carbon is attached with 2 hydrogens. They are same. So this is dead. Dead for GI. So how many active double bonds? 2. So 2 raised to power 2. That answer is 4. The answer is 4. You are able to understand. Keep on showing green hearts if you are able to understand. If not, fire, so that I can understand whether you people are getting or not. Now, if the question they have asked like this, total number of GI by this, total number of GI by this compound, total number of GI. This is the question. Now let me see in the chat who is going to give the correct answer this time. Yes. Let me check it out, kids. Yes. Go for it, kids. Spandana is going for 8. Avinya is going for 4. And kids, those who are news, hit the like button. Yes, at least make it 280. Sahana 4. Okay, so let's see. Kids, first of all, see this carbon. This is carbon and it is attached with 2 hydrogens. These 2 atoms are same or different? They are being same. So this double bond has become dead, means can't show GI. This double bond is dead. So this member of the army, this soldier of the army is dead. Do you think if one army person is dead, then the whole army is going to lose the game? No. Now see, if I talk about this is also attached with 2 hydrogens, they are same. So this is also dead. These 2 are dead. Now these 2 are active. This is active because they are attached with different atoms. Now you will say how? If you see this carbon is attached with hydrogen, one atom is hydrogen and one atom is this much different. R1 and R2 are different here also. Now only 2 active double bond. Now you have to see whether it is belong to case 1 or case 2. Terminal atoms are same or different. Now see, it is showing GI from here to here only. It is showing GI from here to here only. These are responsible atoms. So this is R1. R1 is of how many carbon atoms? R1 is of 2 carbon atoms, 2 carbons. And R2 is of 1, 2, 3, 4 carbons. R2 is of 4 carbons. So do you think R1, R2 same? No, R1 is not same as R2. So 2 raised to power 2, that is 4 is the correct answer. How many of you got it, kids? Do let me know in the chat section. How many of you are able to understand, kids? How many of you are able to understand, kids? Got it? Got it, kids? Okay. So one last type of question. CH3, CH double bond CH, CH2, CH double bond CH2. How many total number of GI? Yes, kids. Once again, I will sit in front of screen and let me check it out. Who is going to give the correct answer? Yes. Everyone's answer is wrong. Everyone is got failed. Everyone is failed. See why? Kids, if I write down one compound like this, now tell me how many GI will be there. Will it show GI or not? Will it show GI or not? You will say no, because this is dead and that is dead. but I would like to say it will show GI. Why it will show GI? It will show GI. See why, kids? If I write down one compound like this, and if I write down R1 anything or R2 anything same or different or same, once they will be up and one they will be up and down. They will exist like this. R1 same side, R1 up, R1 down. So these are two. So this is one stereocenter, n is equal to 1 over here, and this is active, n is equal to 1 over here. So total 2. So total number of GI will be 2 raised to power 2, that is 4. Kids, got it or not? This is one stereocenter. Missed it, and this was brilliant question. How many of you got it now? Kids, do let me know in the chat. How many of you got it now? It's really awesome or not? It's really awesome or not, kids? Hafiz again, okay. See, if I say this is R1 and this total is R2, okay, let me explain on another page, don't worry. Let me explain on another page. This is H, CH double bond CH2, and what is given over there? CH3, CH double bond CH. CH2, CH double bond CH, CH3, right? Now see, these two are up, this is up, that is up, this is dead, leave it. You can consider R. Now, up, in up, this two possibilities are there, and up. This is up, that is up. This is R1, R2, up. Cis. This can be cis or trans when both are up. So two possibilities are there with this. Now this up, this down. Let me draw it. Let's keep it up only, but bring it down. CH2, CH double bond CH, CH3. Now down, this is up, this is down, up, down. There are two possibilities. This is cis and this is trans. So to this. So 1, 2, 3, 4. Now Hafiz, everyone, this is the visualization part. Do let me know how many of you got it, kids. Really, if you have kids, that's why isomerism padikkaradu customer, but Baba will say LL it's romba sulubham. The things which are looking idiyappam muruku will become romba sulubham. Medhuba Arpudham. Kids, completing syllabus is one thing, but taking your all the doubts is next level. Am I right or not, kids? Completing syllabus is one thing. What? Yes, Muhammad Irfan, what's your doubt? Ask me. Yes. Thank you, nothing, thank you. I'm in front of screen only. If you are having any doubt, you can ask me. Anyone, if you are having any doubt, kids, straight away you can ask me. Thank you, Sahana. Avinya, just after optical isomerism, I will start GOC. Yeah, today definitely, kids. Today the whole organic chemistry of class 11th can't be completed. You know, it's very, it is in detail. Baba is not moving like this, just completing. Baba is telling you each and everything. Kids, first of all, do let me know I'm telling you each and everything or not. So, if you go inch by inch, word by word, it's not that easy. It's not that easy. So, the second part I will complete. But now, let's go with optical isomerism. Ready, kids? We are going to start with optical isomerism. Optical isomerism, kids, right? Now, kids, if anyone is asking you what is the necessary condition for a compound show optical isomerism, then what you will say? Yes, kids. If anyone asks you that what is the necessary condition to show optical isomerism, then what should be your answer? The one and only one necessary condition. Tell me, the one and only one necessary condition to show optical condition to be a compound optically active. What's that, kids? Anyone? Let me check it out. Who is going to give the correct answer? Baba will wait for your answer. Here I will write down the answer. In this box, I will write down the answer. Who is going to give the correct answer? I will write down over here. Yes. Let me check it out in the chat section. Who is going to write down? Shruti Bless is writing chiral carbon. Cos and cos. Yes. Jyoti Jain has written 90% correct answer. Jyoti Jain has written 90% correct answer. Compound must be asymmetric. Compound must be asymmetric. Chiral carbon is not the necessary condition. Remember that. Compound must be. Those who have given answer chiral carbon, that is wrong. Compound must be asymmetric. Or disymmetric. And for that, compound should not have, for this, compound should not have plane of symmetry and center of symmetry. Chiral carbon may be present or absent, doesn't matter. Chiral carbon may be present or absent, doesn't matter. Doesn't matter. Chiral carbon may be present or absent, doesn't matter. See kids, eye-opening thing, and that I'm going to tell you kids, that I'm going to teach you. That's why my notes are very, very important kids. Without notes, you won't be able to do anything. These notes are going to play very, very important role, my dear students. These notes holds a hell lot of weightage kids. Are you getting my point kids? Yeah, 7 hours gone kids. How time flies, we don't know. How time flies, we don't know. Now see kids, how to find out plane of symmetry. What is plane of symmetry kids? Just try to understand what is being plane of symmetry. What is the meaning of plane of symmetry? It's an imaginary plane, which divides the whole compound in two equal parts, so that one part is exactly the mirror image of second part. Mirror image of second part. This is plane of symmetry. Now let me explain it through the help of example. Just see, If I draw one letter, A, do you think it is having plane of symmetry? Do you think it is having plane of symmetry? The answer is yes. It is having plane of symmetry. If you divide it from here, this is known as vertical plane of symmetry. Vertical plane of symmetry. Now, if I draw a compound like this, now do you think it is having plane of symmetry? Answer is yes. If you divide it through here, it is having plane of symmetry. Once again, vertical plane of symmetry. Now, if I draw another compound, if I draw another compound, now do you think there is plane of symmetry? Yes. If I divide this compound from here, it will once again have vertical plane of symmetry. It is having or not? Just to let me know, it is having vertical plane of symmetry or not? All they are having plane of symmetry, so they can't be optically active. Plane of symmetry is present. Plane of symmetry is present. Plane of symmetry is present, so they are optically inactive. Optically inactive. Right, kids? They are optically inactive. Till now it is clear. Now, if I say with respect to compounds like, if I draw a compound like this, now there is plane of symmetry or not, kids? Yes. Horizontal plane of symmetry is there. You see, horizontal plane of symmetry, there vertical plane of symmetry. There was vertical plane of symmetry. Vertical plane of symmetry was present over here. So, in this, horizontal plane of symmetry is present. Am I right or wrong, kids? Sandwich cut, horizontal plane of symmetry is present, kids. Plane of symmetry is present. Now, if I draw one compound like this, now do you think there is any plane of symmetry? No pause. No pause. So, this is optically active. Now, this was about alphabets, but let's come to the chemistry compounds. If I talk about chemistry compounds, I will draw like that carbon, and with this you will understand what is the importance of chiral carbon also. CH4 or CCl4, this is one category. Now, if I write down CH3Cl or CHCl3, this is another category. If I write down CH2Cl2, if I write down CH2ClBr, and if I write down CH chlorine, bromine, iodine, then I would like to say in this category pause is present, 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 here pause is absent, not present, so only this compound is optically active. This is not the end, kids. This is the starting. Now, how many of you want to understand that? How many of you want to visualize actually? How many of you want to visualize what is being plane of symmetry? What is the meaning of plane of symmetry, kids? How many of you want to visualize actually? Do let me know. Okay, now see, kids. To visualize it, you should know tetrahedral. Tetrahedral is very, very important. Just see tetrahedral. Now, if I say that if all the atoms are same, just first try to understand the V. Then only you can do anything. Just try to understand. If I say this is 1V, can you see this is 1E? Right now 90 degree, now 109 degree. Can you see 109 degree? Now bisecting it, if I say all the 4 atoms are same, CH4. Now can you see the first case, CH4 or CCl4? Can you see all? If I say all, they are same, and if you cut it like this from here, cutting like from here, cut it, then this atom will go half towards right, half towards left. The middle carbon half towards right, half left. These two are same, and this will go half towards right, half towards left. Plane of symmetry is there. Can you see? Rappa, rappa, cut it. Rappa, 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 cut it. Will you get plane of symmetry or not? Just to let me know in the chat section. Hurry up, green signal if you are getting it. I want to see green signal, because this visualization will give you full marks, and this visualization is required for full organic chemistry. Getting it? Rappa, up, cut it like this. Will you get? Show me green hearts if you get plane of symmetry. Okay. Now, if I move towards second case, 1 is same, rest of 3 are different. So let me keep 1 as this as another page. Let me say let me change it. I've changed it. This is different, this is different, this is different. Rest of 3 are same. Rest of 3 are same. Can you see? Rest of 3 are same. This is different. Now cut it. Now cut it. This half will go toward this side, half will go toward that side. This one half will go towards right, half towards left. This and this same, and this is same. Plane of symmetry is there. Yeah, plane of symmetry is there. Now I will change 2. This case will change 2. Okay. Now see, if I say that this V is okay, this V though it's okay, this V is okay, this though it's like that only, right? Now 2 are same, and let me make 1 towards your side, this one, and 1 remote towards my side. Remote, this I have changed, and this I have changed. 2 I have changed. These 2 I have changed. 1 this and 1 remote, right? Now cut it. If you cut it from here, this paper half towards right, half towards left, and these 2 are 1 towards that, 1 towards this side, and half towards right, half towards. Plane of symmetry is here, right? So this is also having plane of symmetry. And now this is same. If I change, already I have changed, this is different, this is, so they. Now if I change all 4, I change all 4. If I change all 4, 1 this, can you see visible? Now 1 this one, 1 this one. Let me change all 4. Now 1 this one, bottle, this bottle, 1 bottle, this one. Let me change all 4. And let me take then this remote, all 4. Now see, if you cut remote half right, half left, but this and they are different, and bottle half towards right, half left, it's okay. But see this paper right hand side and left one, there is no plane of symmetry. Can you get it? I hope kids you got it. There is no plane of symmetry in this one. In this one there is no pause, no pause, no pause. You got it when all four are different. Kids, let me see in the chat you are getting or not. Thank you kids, thank you. And kids, this is known as chiral carbon, and that's why mostly people are getting confused. When chiral carbon is there, compound is optically active. People start thinking like this because in your school this is valid. Up to school level it is valid because in school only one chiral carbon chemistry is there. In a school level, up to school level, let me tell you, up to school level only one chiral carbon chemistry is there. Let me tell you, in school chemistry of only one chiral carbon is there. That's why those who have studied in school, they always speak like that. If chiral carbon is there, compound is optically active. But this is not the world. This is not the competition level. Competition level is not like this. So one thing we can understand from school level also, if in a compound, if there is only one chiral carbon, what information we can get from school level, that in a compound if only one chiral carbon is present, then the compound will always be optically active. Then the compound will always be optically active. This information we can get from school. But if a compound is containing more than one chiral carbon like tartaric acid, mesotartaric acid, then this is not valid. Then school level will get failed. For more than one chiral carbon, this chemistry will get failed. So we have to understand plane of symmetry only, kids. Okay kids, now if I take a compound like this, now try to find out whether plane of symmetry is there or absent. Just try to find out. This is rank deciding question, kids. So it becomes very, very important. The two chlorine are up, so it is cis. Now one chlorine up, another chlorine down, trans. Now what do you think? In which one plane of symmetry is there? Cis or trans? Which one is having plane of symmetry? Do let me know. Just everyone, just do let me know which one is having plane of symmetry. Which one is having plane of symmetry? Do let me know. And kids, smash the like button if you're really getting it. If you're new, kids, if you're new to this channel or new to this session, make it 300, kids. At least only 10 to go for 300. Yes. Tell me which one is having plane of symmetry. Cis is having, Sahana is saying both of these not having. Let me check it out. Everyone just see and tell me which one is having plane of symmetry and which one is not having. Let me check it out, kids. Who is going to give the correct answer? Let me check it out. Who is going to give the correct answer, kids? Okay. See, kids, if I say this is your cyclobutane, right? This is your cyclobutane, okay? Cyclobutane. And if I say this is chlorine, okay? This is chlorine going up and this is chlorine going down. Can you see? Now diagonally cut it from my neck, cut it, or from here you cut it. By cutting it, half it will go right hand side, half it will go left hand side, and it will be divided in two equal parts or not. Just check it out. Or you can cut it like this also. From this diagonal, if you cut it, it will get divided in two equal parts or not. Just see. Cis is having plane of symmetry. Now check, if I make it downside, now just check it out. If I make it downside, kids, downside, one is going downside. Just see, kids, one is going downside. Can you see? Is it visible? And one upside. Then also if you cut it diagonally, rappa, if you cut it, half will go right hand side, half will go left hand side. And if you come over here, this lower one will also, half will go upside, left hand side, and half will go right hand side. Can you see, kids? Can you see, kids? Half will go, just check it out, and if you can't see, you see it like this, kids. Both of them are having plane of symmetry, diagonal plane of symmetry. Got it, kids? Both of them are having diagonal plane of symmetry. Don't say sorry, it's our studies. So if you cut it like this, if you cut it like this, it will get divided in two equal parts. Got it, kids? It will get divided into two equal parts. Will get divided on a diagonal plane of symmetry. I would like to say it's being diagonal plane of symmetry. Diagonal plane of symmetry, kids. Do let me know. Will get divided or not? Today really you are getting the best way of teaching, the best way of understanding diagonal plane of symmetry, and here also you will get diagonal plane of symmetry. Just check it out, kids. Diagonal plane of symmetry is present over here also. Diagonal plane of symmetry, just check it out, kids. Just check it out, kids. Diagonal plane of symmetry is present or absent. See, diagonal plane of symmetry is present. So both of them are optically inactive. Got it, kids? Till now it's clear to each and every one of you, not, kids? Do let me know. Engulfing it, okay. That's really awesome. That's really awesome, kids. Now, kids, yeah, it's dichlorobutane, 1,3-dichlorobutane. Now, kids, let's take a break. Kids, let's take a break. Then I will continue with optical isomerism because long way to go. So let's meet at right now it's 7:25. So let's meet at 7:55. 7:55. Let's meet at 7:55. Okay. Come with ATPs, high energy ATPs. Okay, kids. Okay. Hey kids, what's up? Baba is back 1 minute early only. Now, just to let me know, how is everyone, kids, kiddo kids? What's up, kids, what's up? Hey everyone, kiddo kids, just to let me know, what's up? What's up? Okay, so I've told you plane of symmetry. So plane of symmetry is important. So if I talk about plane of symmetry, how much it is being important, kids? Great examples we have seen, kids. Now kids, are you there? Are you there? Everyone, are you there? Very good, kids, very good. That's Nalla Iriku Romba Selvam. Now kids, today we will complete up to isomerism. GOC we will start in next turn. Second part of it, GOC and hydrocarbon. We will complete GOC and hydrocarbon in second part, right? Kids, GOC and hydrocarbon we will complete in second part. Are you ready for isomerism, optical isomerism? Now, plane of symmetry is how much important, kids? I want to see green hearts from everyone's sides. Hey kids, I want to see green hearts from everyone's sides. Plane of symmetry is 99% important, and we should have an idea about center of symmetry. Center of symmetry, very rarely asked 1%, because very rarely asked. Very rarely asked. Okay kids, very rarely asked. Now what is center of symmetry? If I talk about, if I draw one compound like CONH, CH2, CONH, and if you sit just in the center, here at the center, and if you move in the opposite direction, kids, if you go in the opposite direction, what you will get? CH2, this side CH2, NH, that side also opposite, vertically opposite NH, CO, then vertically opposite you will get CO, bond vertically opposite, oh my god, what is this? Bond vertically opposite you will get bond vertically opposite you will get bond. Can you see, kids? Whatever you see vertically opposite you are getting, this is known as center of symmetry. Clear kids? Clear to all of you? Are you getting my point? Everyone, is it clear? Just to let me know, kids, is it clear to each and everyone? Very good. Prithvi, good evening. Now see, kids. Now, calculation of total number of chiral carbons. Calculation of total number of chiral carbons. Just see, carbon attached with 4 different atoms is known as chiral carbon. You can say chiral carbon, chiral or asymmetric carbon. Now see kids, if I write down compound like this, then how many chiral carbons are there? Just see, this carbon is attached with 4 different atoms or group and this, so it is having 2 chiral carbons. If I go towards another compound, just try to find out. If I draw this compound, then how many chiral carbons are there in this compound? Just to let me know, let me sit in front of chat. Just try to find out how many chiral carbons are there, kids. Everyone just find out how many chiral carbons are there. Do let me know, kids, how many chiral carbons are there. Fast kids. G1 is going for 0. Kids, if you see this carbon, this is attached with hydrogen, this group, 1 carbon, but this carbon is attached with this and 1 CH2. All 4 are different. So this is chiral, this is chiral, this is chiral, and this is chiral. 4 chiral carbons are there. 4 chiral carbons are there. Can you see? Can you see? And there is no symmetry. So total number of optically active isomers, I will let you know how many optically active isomers. But you see, can you count the number of chiral carbons? Now let me tell you how to find out total number of optically active compounds. Total number of optically active compounds. Now for this, I will say case number 1. Case number 1. Now, what is this case number 1? That is very, very important thing. Remember that when compound doesn't have any pos or cos, in any of its representation, then total number of optically active isomers, what is the full form? Total number of optically active isomers is equal to total number of optical isomers is equal to 2 raised to power n, where n is equal to number of chiral carbons. Number of chiral carbons gets number of chiral carbons, and the full form of this, total number of optically active isomers and total number of optical isomers. Why they are same, I will let you know, kids. Total number of optical isomers, right kids? They will be same. Now you will come to know that why they are same when I will tell you case number 2, then only you can understand. But right now you have to focus over here. And let's say if I draw the compounds, so if I draw this compound, CH3, CHCl, CH3, this is having only 1 chiral carbon, so 2 raised to power 1, that is 2. Out of 2, one is being dextro, another one is being levo. And dextro and levo, what relationship they are having? They are enantiomeric pairs. Enantiomeric pairs. Enantiomeric pairs. Now if I write down compound glucose, if I write down compound glucose, do you know glucose? Now see, CH double bond O, CHOH. Find out how many chiral carbons are there, kids. How many chiral carbons are there? So you see 1, 2, 3, 4. So 2 raised to power 4. 2 into 2 into 2 into 2. 2 to the 4 to the 8. 16 optically active isomers are there. Can you see, kids? Are you getting my point? Now if I write down fructose, but remember that if I write down closed chain structure of glucose, this question has been asked, it's closed chain structure of glucose, CH2OH, 2, 3, 4, 5, oxygen. Now this HOH, 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 they can write ring chain structure. They can write ring chain structure, or they can write pyranose structure, or they can write paranose, hemiacetal ring structure, or they can write alpha D glucose. Whatever they are writing, they all will have one extra chiral carbon. 4 these and 1 anomeric carbon. This is extra chiral anomeric carbon. Are you getting my point, kids? Anomeric. So 5, total 5, 2 raised to 5, that is coming out 32 optically active isomers. Is it clear till now? If it is clear, show me green hearts in the chat section. Let me check it out. How many of you getting, kids? Fast, fast, fast. At 9 I will end this session. At 9 session will get ended. So don't worry, kids. At 9 I will end this session. Okay. Notes PDF I will send. I will send the PDF. Don't worry, kids. Thank you, Jyoti Jain. Thank you. Okay. Now see. Case number 2. Case number 2. Just see case number 2. Case number 2, when any compound does have pos or cos in any of its representation, in any of its representation, then remember that 2 subcases will arise. Then 2 subcases arises. Just like geometrical isomerism. Remember, 2 subcases arises. What are these 2 subcases, kids? When n is equal to even, when n is equal to odd. Do you remember, kids? Do you remember? Now let's first deal with even and then with odd. Okay, first with even and then with odd. N is equal to even. The best example of it is, kids, tartaric acid. Remember that, tartaric acid. Tartaric acid is the best example. What is the formula of tartaric acid? COOH, CHOH, CHOH, COOH, right? How many chiral carbons are there? 2 chiral carbons are there. This is being chiral and this is being chiral. How will you represent it? Just see, kids. Now see kids, focus over here. If I write down OH, OH, COOH, H, H, COOH. Now you see, if you try to divide this compound in two equal parts, you won't be able to divide. If you divide it from here, upper side is OH, downside is H. No plane of symmetry, no pause. So it is optically active. It is optically active. If you see that if you remove from OH to H, it is moving anti-clockwise, and same you have to rotate OH to H anti-clockwise, same direction. Although this is not RS system, but I am just telling you for simplicity so that you can understand. It's mirror image. If you put a mirror image in front of it, what you will see? OH, H, H, OH, COOH. This is just the mirror image of it. So light, you will feel that OH to H is going clockwise, OH to H is going clockwise. This is also same direction, no pause. So mirror image will be optically active. So these two are optically active. If this is dextro, that will be levo. If this is levo, this will be dextro. What is the relationship they are having? They are enantiomeric pair. And enantiomeric pairs are always optically active. Now, if you see OH, OH, H, H, COOH, COOH. Now you see this compound is having plane of symmetry. If you try to divide this compound, you can divide this compound in two equal parts from this place. Just see kids. This compound is having plane of symmetry. Can you see kids? This compound is having plane of symmetry. Can you see kids? Everyone just see this compound. You can divide in two equal parts. Can you see kids? This is the plane of symmetry. So it is meso. Now, meso, kids, what is meso? It is having two chiral carbons, one chiral, another carbon. As I have told you, chiral carbon is not the necessary condition, even though this compound is having two chiral carbon, but is optically inactive. Optically inactive. It is optically inactive. Why? Because it is having plane of symmetry. So plane of symmetry should not be present. Remember that. And if you rotate the light, try to rotate the light, this is moving anti-clockwise and the half portion will rotate the light in clockwise. So due to internal compensation, due to internal compensation, it is optically inactive. And the mirror image of meso is always meso. So they are identical, will be treated as same one compound. So total 3 isomers are there. These two are optically active as well as optical isomer. This is optically inactive but optical isomer. Kids, how many of you got it? Just do let me know in the chat section. How many of you are able to understand? Do let me know in the chat section, kids. Wow, Abhinya. Kids, now. So what is meso? Let me write down the definition of meso. Let me write down the definition of meso. Meso means optically inactive due to internal compensation or the second definition I can write having plane of symmetry even though or along with chiral carbons, having plane of symmetry along with chiral carbons, along with chiral carbons. right? So such type of compounds are known as meso, and very special about meso is meso compounds are optical isomers. They will rotate the light, but if I move like this, 50% like this and 50% like this, I will come at the same position. So this happens with the meso. Whatever magnitude they are rotating in the clockwise, the same magnitude they are rotating anti-clockwise. So they becomes at the same position. So they are optical isomers, but optically not optically active. Not optically active. What is the meaning of this? That suppose I am a plane polarized light, I was moving like this, meso compound has rotated like this, sabki pasand nirma, and anti-clockwise like this. Now when I move out of that tube, I will go like that. I have not been rotated. So it's like this. Now with the formula I can find out. See, formula wise, let's apply formula and let's see how many isomers are coming. Formula for optically for tartaric acid, same formula, just for GI I have applied. Total number of optical isomers, that is equal to total number of optically active isomers plus meso isomers. So the formula will go like this: 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to n plus 1 by 2. No, that was for odd. P is equal to n by 2, simply n by 2. Now apply the formula. 2 chiral carbons were present, so 2 raised to power 2 minus 1, total number of optically isomers, and 2 raised to power 2 by 2 minus 1. So this will come out 2 optically active and 1 meso. So total 3. 2 are optically active and 1 is meso. Got it? This is formula wise we have got the answer. I hope that everyone got it, kids. I hope that everyone got it. Do let me know, kids. Everyone just do let me know. Now, if okay, which one, Sana? Where? It's Cl. It's chiral. It's written chiral. This is chiral. Sahana, it's chiral. This one you are talking about, Sahana? Sahana, are you talking about this one? Just to let me know. It's chiral. It's chiral. That is chiral carbon. Sahana, that is chiral carbon. Got it? Just see, I'm seeing your messages also. Any doubt? I'm solving to solve it. Kids, I'm going through each and every doubt of yours. See, I'm going through each and every doubt of yours. Just see, kids. I hope that everyone is getting okay now. Now one example of odd one. See, odd one. When n is equal to odd, Board is not working. Board has got tired. Board has got tired up. Stopped working, kids. Stop working. Yeah, now it will work. When n is equal to odd, only one type of example will come like this. See, this example has been asked COOH, CHOH, CHOH, CHOH. Now 3 OH are there. COOH. Any type of example they can ask. This example they can ask, or they can ask like this: CH3, CHBR, CHCl, CHBR, CH3. They can give like this, or they can give another example like this: COOH, CH, CL, CHCl, CHCl, COOH. You see in XYZ, one thing is very common. If you sit in the center, you will get symmetry. See? Same thing you are getting. You will see same thing, right? So one thing is that 2 optically active and 2 meso. You can cram it out. All they will have 2 total number of optically active isomers and 2 meso. So total will come out 4 total number of optical isomers. Now you will ask why. How many of you want to know why? Kids, do let me know how many of you are interested in why. Why it's like this? Ask me why it is like this, kids. Ask me why it's like this, kids. Kids, fast. Fast. Fast, kids, fast. Now see, kids. Very good, very good. Now see, kids, everyone see. Let me explain. Let me explain. Let me take any one example and explain it. See, if I write like this, COOH, COOH, OH, OH, H, OH. How many chiral carbons are there, kids? 1, rand, mono. 3 chiral carbons are there. 3 chiral carbons. At all 3 chiral carbons are there. Can you see? 3 chiral carbons. And no plane of symmetry is there. If you divide it, see, that side hydrogen, that side OH. So no pos, no cos. So compound is declared to be optically active. Am I right, kids? Now if you see its water image, you will see it like this. You will see like this, it's water image. Am I right, kids? H, H, OH, COOH, COOH, and this OH going away. This OH is going away. The H is going away. So same for this optically active, same for this. So they are having enantiomeric relation. Two are optically active and they are enantiomer of each other. Am I right, kids? So two are optically active. Now see, kids, they are having 3 chiral carbons. All 3 carbons are being chiral. Just check it out. But at the same time, if I draw it like this, see, kids, OH, 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 what will you say? There is plane of symmetry or not? Just check it out. Is it having plane of symmetry or not? Let me see the chat that you are getting it or not, just to let me know. Is this compound having plane of symmetry or not? Yeah, right. Now see, kids, it is having plane of symmetry. Can you see? It is having plane of symmetry. Can you see, kids? Can you see, kids? This is having plane of symmetry, and due to plane of symmetry, just see, kids, this is chiral carbon, this is chiral carbon, but from where the plane of symmetry passes, that becomes not chiral. Remember that. From where the plane of symmetry is passing, this becomes not chiral. So see, this compound, see, there it was chiral, here it was chiral, but in this example, this is not chiral. And this compound is having plane of symmetry, so it has become optically inactive. And what I will say, it is being meso. I will call it meso. Got it? I will call it meso. Now see another one compound, you will get shocked. Just see another one compound, definitely you are going to get shocked. So after giving questions, I sit in front of screen just to check your answer. Now see, this is another compound. I will sit in front of screen to check your answer. This compound is having plane of symmetry or not? Is this compound having plane of symmetry or not? Is this compound having plane of symmetry or not, kids? Present. Very good. Plane of symmetry is present. If you divide it from here, This will get divided in two equal parts. Just see. It will get divided in two equal parts. Can you see, kids? So plane of symmetry, but this meso is different from this meso. And see, this carbon is chiral, this carbon is chiral, and once again this carbon is not chiral, and plane of symmetry is present, so it is meso, meso, meso. So two meso and two optically active. So now you must be shocked that, sir, what to say about the middle carbon? Is it chiral or not chiral? So people, they always say in the condensed formula, this is chiral, but the middle carbon is known as pseudo-chiral. What, kids? Pseudo-chiral, false chiral in all three. Chiral, these are chiral, but these are known as what? Pseudo-chiral. Or prochiral, they call it prochiral. I hope that you are getting, kids. Everyone is able to understand, kids. Do let me know in the chat section that everyone got it. My dear friends, just to let me know everyone is able to understand. Everyone is able to understand, kids. Very good, kids. Very good. That's really awesome. That's really awesome. Now see, kids. Now, let me give you examples of compounds which are chiral without having any chiral carbon. Let me show you compounds. One is compound is chiral and one is compound is having chiral carbon. Have you ever heard this term? Have you ever heard this name? Compound is chiral. Compound can be chiral with chiral carbon or without chiral carbon. Have you ever heard this name? Compound is chiral. Remember that. Compound can be chiral with or without chiral carbon. Now, kids, you will definitely ask how the compound is chiral without chiral carbon. So, what is necessary for a compound to be chiral? Compound will always be chiral that is asymmetric that is disymmetric if it is not having what, kids? Pos and cos. Now, let me give you examples. Of chiral compounds, that is optically active compounds. without having any chiral carbon, without having any chiral carbon. First example is allene. Second example is pyrenes. Third example is biphenyls. Remember that they must be properly substituted. Properly substituted. Once this is getting clear, this session will get over, kids. Now, these three I will explain one by one in detail. Are you ready, kids? I will explain all these three in detail. Just do let me know. Are you ready? Kids, do let me know. Are you ready to understand? Very good, very good. Lucky Chand, very good, very good. But right now, no chance. Prepare, work hard. Definitely you will get selected. Now, see, kids. First, allene. Let me have a sip of water, kids. Let me have a sip of water. Now, see. What is required by allene? If I write down compound, and this compound already I have explained, kids, if you remember. If you remember, do you remember? This compounds, if I say the hydrogen is coming towards your side, do you remember that? That bed one, do you remember? Hydrogen is coming towards your side, methyl is going away from you. If this is on the bed, that means it is horizontal, then its pi bond will be vertical. Do you remember? Vertical pi bond. Now, if this pi bond is being vertical, kids, then this pi bond will be once again horizontal, kids. This pi bond will be horizontal. Are you getting my point, kids? Everyone just to let me know. This pi bond will be horizontal, kids. Now, if it is being horizontal, then the sigma bond will be vertical. Sigma bond will be vertical, and if I say this methyl is coming over here, this hydrogen is placed over here. Now, if you try to cut it, if you cut it, this hydrogen will come half of the portion towards your side, half away from the board, and half this side, that side. But when you come over here, this hydrogen will come toward this side, and methyl will go over that side. Suppose I am the compound, this is my head, hydrogen is my head, methyl are my legs, and this is methyl and this is hydrogen. If you cut my head, half of the head will go that side, half of the head will go this side, body half that side. But if you once you come over here, this is hydrogen and this is methyl, plane of symmetry will not be there, because you go like this, that side methyl, this side hydrogen. But if you cut it like this, sandwich cut, so half of this hydrogen will go up, hydrogen will go down, methyl will go up, methyl will go down. But once if you cut sandwich, you will go like this through my body, head will up and legs will come down. Got it, kids? No plane of symmetry is there. No plane of symmetry is there. No chiral carbon is there. But still compound is optically active. Compound is chiral because compound is optically active. How many of you understood? Did you understand? If you got it, if you have understood, I want to see green hearts. Kids, Baba is putting all of his efforts. Kids, Baba is trying his level best to tell you each and everything. Just do let me know, kids, you are able to understand or not. Very good, kids. Then smash the like button, kids. Hit the like button. It's 318. Let's make it 325. Let me see. Can you do that? Let me check it out. Can you do that? 325 from 18 to 25. Let's see how many of you can do that. Let's see the magic. Okay. Now kids, if it would have been odd, then GI, even then OI, GI, OI. Now let's see spirine. I will make spirine from this only. Just see, I will make a spirine from this only. So let me say this was the bed. Do you remember this one? Everyone, do you remember this one? Do you remember, kids? Now see, kids, this is bed as I have told you. Let me copy it so that I can make everything possible, kids. Now see, kids, if I put one carbon at this place, one carbon at this place, one carbon at this place, right? 3 carbons. Now sigma bonds. Now if I remove these sigma bonds, as allene I have made, if I remove these sigma bonds and if I say this bond is coming towards your side, this hydrogen is coming towards your side, kids, right? Let me draw like this, that hydrogen is coming towards your side, right, kids? And this is lying on the bed. This hydrogen atom is on the bed, right? Bed. And this methyl is also on the bed, right? Now they are horizontal. They are placed horizontally, as I have told you, horizontal, right? On the bed. This is also horizontal, right? So its pi bond will be, tell me, pi bond will be, kids, pi bond will go vertically up and down. These 2 lobes will go up and down. Am I right, kids? You are able to understand. It's, but in place of pi bond, if I put cycle, then that will go vertically up and down. This will go like this, vertically up and down. It will go like this, vertical, it will go vertical, just like pi bond. And the whole cycle will be vertical, right? It's vertical, kids. Are you getting my point? Now another pi bond was horizontal, so another ring will go horizontal. So horizontal will look like this. this is horizontal, this is horizontal. Then kids, tell me the sigma bonds will go, this is horizontal, vertical, this is horizontal, this ring is horizontal. Just let me draw it so that you can understand it. It is vertical, kids. It's vertical. Can you understand? It's vertical. It's being vertical, vertical, and this is being horizontal, horizontal, right? Okay, kids, can you understand what I am trying to? Now, this is horizontal, then sigma bonds will be vertical, vertical, vertical. This line will go vertical, and here, let us suppose hydrogen, and here suppose methyl. Now see kids, try to understand. Once again the same thing, just like allene, just see the same thing, same appearance will be there or not. No plane of symmetry. I have tried a lot kids. Let's check it out whether you are able to understand or not, my dear students. 3D diagram, I have added all my efforts. Only 15 minutes to go. Just in 15 minutes it will get over. Rest of the half portion of class 11th I will take another day. Yes, yes, yes. Along the bed and above and below the bed, no pause, no cause, no chiral carbon. Once again I would like to say, no chiral carbon, no pause, no cause, but compound is still optically active. Compound is optically active. Spiranes, these are spiranes. Now kids, one is left. Ortho substituted biphenyls. But how you're liking kids? First of all, do let me know today how much in detail you have got it kids. Completing syllabus is not a big deal, not a big deal kids, but completing in a proper way, that means a lot, that means a lot. Completing in a proper way. Now kids, see. This bed one example is good or not? Bed one example is good or not? Because we always sleep on bed, so we can understand it in a proper way, that what is plane, what is going up, what is going down, we are getting it. Now see kids, if I draw two phenyls, then the phenyl rings will look like this. One phenyl, another one phenyl. Now just to let me know, this is biphenyl, there is plane of symmetry or not? Is it having plane of symmetry? Yes. Because if you cut it from here, there is plane of symmetry, this is plane of symmetry. If you do the sandwich cut, if you do the sandwich cut kids, if you cut it like this, sandwich cut, then also plane of symmetry is there. Sandwich cut, from anywhere if you cut it, there is plane of symmetry. Can you get it kids? This is plane of symmetry over there. Am I right or wrong kids? Am I right or wrong? This is plane of symmetry. If you cut it, it is having plane of symmetry. It will get divided in two equal parts. So vertical plane of symmetry as well as horizontal plane of symmetry. Two types of plane of symmetries are present over there. Just see kids, two types of plane of symmetries are present over there or not. Everyone just do let me know, two types of plane of symmetries are present there or not. Two types of plane of symmetries are present over there or not. Everyone just do let me know. Can you understand? Thank you, Jyoti Jain, Hemlata Hasni. Now, this compound is having plane of symmetry. Parama, no one can teach this much detail, Baba. Thank you. I want Parama this type of comment I need once the session is over. Wow, really awesome. Really awesome, Parama. Really awesome. Now, right now this compound is having plane of symmetry, so it is optically inactive. Plane of symmetry is present, so optically inactive. Now kids, if I put if I add any group anywhere, then also plane of symmetry will be present. Suppose if I add NO2 over here, COH over here, NO2 over here, COH over there, same plane of symmetry is present, optically inactive. If you place smaller groups over here, fluorine, chlorine, bromine, then also optically inactive, nothing will happen. Sir, what you want to prove? Where, which direction, what you want to say? Tell us. Thank you, Dream TMC. Now see kids. Thank you, Hemlata Hasni. Thank you kids. I want these type of messages and these messages directly in the chat section once the session is over. Will you put? First of all, make a promise that you will add over there once the class is over. Hemlata, Parma. Now see kids. Now something is going to happen. Remember that when you put what? Now see what is going to happen, kids. Now when you add bigger atoms or groups, what are bigger atoms or groups, kids? NO2, COOH, NO2, COOH, NO2 or COOH, NO2. Now all the four ortho positions, I'm talking about all the four ortho positions occupied by bigger groups or atoms. Remember that all the four ortho positions occupied by groups or bigger atom. What are bigger atoms? Or bigger atoms like bigger atoms. What are bigger atoms? Like iodine or bromine. Iodine and bromine are bigger atoms. This place iodine and bromine can be present. Now see kids. Suppose if I say there are two people standing, the two rings are like this. Let me draw first of all. If this is one ring, just try to understand because visualization is very, very important. Suppose if these are two rings, right? These are planar. Now if you cut it from the middle, suppose these two are same. If you cut it from the middle, there is plane of symmetry. Can you see? There is plane of symmetry. And if you cut sandwich like this, then also plane of symmetry is there. But at ortho position, if you put groups NO2, COH, NO2, COH, then do you think in this much of space, four groups, one ortho, one more ortho, one ortho, one more ortho, at this place, then the ring will go like this, ring will move like this, ring will move like this, one ring will go like this, vertical, and vertical rings NO2 will go up, COH will go down, and its NO2 will come toward this side and COH will go that side. Now if you try to cut, if you try to cut, see, let me cut it first, let me cut it like this, then I will come over here, NO2 half that side, this side, COH half this side, this, NO2 half that side, half this side, COH half that side, this side. But once if I come over here, then COH on that side, NO2 this side. I was cutting like this, so that side NO2, this side COH. Remember that these two should not be same. If one is NO2, another one should be COH, two must be different. On each ring, two groups must be different. If this is NO2 and that is NO2, both are being NO2, then plane of symmetry will take place. They should be different. Whatever the side you can place, that side or this side doesn't matter, but these two should be different, these two should be different. Now, you said that it is violating the rule, so you will start cutting sandwich. Sandwich you will cut NO2 half up, half down, COH half up, half down. But once you come over here, this NO2 is going up, COH is going down. These should be different, no plane of symmetry. Got it? I don't know whether you got it or not, kids. Do let me know. Got it? That means half of this is vertical ring, this is vertical ring, this is vertical, this is vertical one, this is vertical, now that is horizontal. The two rings are having different plane. These two rings are in different plane. Just see, this ring is in different plane, this ring is in different plane, kids. See, it is horizontally lying. That means here the two rings are not in same plane. Two rings are not in same plane. Two rings have got different plane, kids. Just see, these two rings have got different plane. These two rings are in different plane, that's why there is no plane of symmetry. Earlier two rings were having same plane, two rings were in same plane. Now two rings are not in same plane, rings are in different plane. Rings are in different plane, so no pause, so optically active. And this type of so first of all, do let me know in the chat section you got it or not, kids. You are able to understand or not. Yeah, I will provide the PDF. Kids, do let me know you got it or not, that two rings are in different plane. Their plane is being different. Kids, do let me know. Everyone. There is one norm, yeah, the atrop isomerism. Its name is known as atrop isomerism. It is known as atrop. This type of isomerism is known as atrop isomerism. Atrop. Technical name is atrop isomerism. Now kids, if I ask one question which is optically active, this is going to be the last question of this session, which is optically active. Okay, question is, which is optically active? A, chlorine, bromine, iodine, bromine, chlorine, fluorine, NO2, COH, NO2, NO2, COH, fluorine, chlorine. Let me see the answer in the chat, kids. Wow, kids, wow, you are really awesome, really awesome, really awesome. You have done it. Done and dusted, kids, done and dusted. Now, very good. A is correct. Now, kids. Now, kids, do let me know how was the session. I've completed IUPAC, very basics, isomerism, but I have told you each and everything in detail, kids. I have not just tried to finish it off. I have tried my level best, kids. So a humble request, kids, take care of yourself. Talk to your parents whenever you get time, your brother, sister. Not for too much time, but whenever you get time, that will decrease your pressure. Remember that we are over here as a team, as a family, and myself, you know, people call me Baba. You know, my dear students, Baba means what? In south side, Baba means father only. So I am your teacher parents. I am here to take care of you people. We are over here as a team to take care of your studies. And kids, whenever you feel low energy, you can talk to us. You can just put a message. We are over here to help you. Any doubt, any query, whatever the problems you are feeling, kids, we are over here to help you out, kids. Always. But before leaving it, let me tell you one very, very important point, kids. Very, very important. All GI are diastereomers. Remember that. All GI are diastereomers. Or you can say diastereomers are those stereoisomers which are not mirror images of each other, which are not mirror images of each other, or we can say all 3 points I am going to tell you. One I have told you, second I have told you, the third one, all those stereoisomers which are not enantiomers, are always diastereomers, Very, very important point. I missed it. So when I was talking to you, just click to my mind, that's 3. Jeevan, thank you. That conformational we will do in hydrocarbons, kids. Conformational we will do in hydrocarbons. Bye to all of you, kids. Conformational we will do in hydrocarbons, right, kids? So, good night. Shabba khair. Bye to all of you. God bless you. Love you, kids. Bye-bye. 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 Don't forget to add comments once the video is over.